Good morning. It is 9 o'clock. Thank you for joining us today. This is the TASIG annual meeting, Texas Ancillary Structures Interest Group, for those of you that aren't aware of that. This is our third one that we have had, and I do appreciate all of the interest in it, the feedback we've been getting, the information that, ways for us to progress in the design and fabrication and just getting everyone to talk to each other. So it's been really great. I will start with some housekeeping things. So we do have some virtual attendees. This is hybrid. The virtual attendees are muted. And if you have any questions or comments, please put them in the Q&A. I do have somebody checking that. So they will be our voice for the virtual attendees. In-person attendees, make sure you've registered. It just kind of helps with us keeping track of things. We also have a sign-up sheet in back and paper agendas. I like the paper so that if you want to take notes, you can do that too. You have something to write on. There is a coffee bar just past the turnstiles or the security desk if you guys want coffee. Lunch is going to be off-site, and there are restrooms just right outside this, outside the doors. So if you want a visual, I do like my visuals. The yellow is the room that we're in. The blown up view on the right is, you can see very clearly the room that we're in. There's a fire extinguisher. We also have, you can see where the restrooms are. And then we'll see if this works. The lobby. So if we do need to exit, we'll go out the lobby, the front doors. So the Texas Ancillary Structures Interest Group, just kind of as a refresher, as an overview, we have been doing this for 3 years, but I know there have been new people coming on board. So this is a joint owner industry forum aimed at guiding, advancing, and improving ancillary structure aspects. This includes design, fabrication, construction. We're trying to look at it from all angles so that we can develop good details and practices that are used down the line. So the goals are industry feedback, industry education, to advance our design, details, fabrication, and construction, and address procedural and performance issues. So if we're seeing something in the field that can be addressed with better details and design, then let's go ahead and implement those in our standards. There is a web page that you can get more information on. On this web page, after this meeting, give me at least a week, we'll post the presentations as well as the recording. And please note that this is being recorded, so that is your notification on that. There is an email address that you can send questions specifically to about TASIG or industry questions. And for today, so this is the agenda, and on the bottom you can see the username for the TxDOT GuestNet Wi-Fi and the Wi-Fi password. It's also on the whiteboard over there in case you need it for later as well. So it is heads up, phones down. We're starting with the welcome, and then we're going to move on to just general updates for TxDOT, and then 2024 specification updates. And then after the presentations, there's always an open discussion so that we can kind of discuss it, get more into the details if people have questions or discussion items, feedback. We also have a presentation about the different research going on right now. We've got the geotechnical updates as to how to use our standards. Since we're moving to the LRFD and things like that, there have been questions coming up about that. And then at the end, there's a quick peek into kind of resources that are up and coming. I know I've been saying that for a couple of years, but we do actually have some visuals. We're getting closer and closer to actually finishing up reviews on those. So we have some details on that. And then we will adjourn at 3. So with that, we'll hop into TxDOT updates, and Raphael with the Traffic Safety Division will come up here and talk about their updates.
All right, thank you, Courtney. Again, my name is Rafael Riojas. I work for the Traffic Safety Division. I'm the Policy and Standards Branch Manager, and so essentially my group's responsible for all the traffic safety standards. So we're responsible for them, but we rely heavily on Bridge to tell us what needs to go in there structurally, so we appreciate that. But just kind of want to go over some of the updates that we've recently released. So we recently released a large road sign mounting detail updates, updates for large, summary of large signs, high mast illumination details. We removed some standards and we'll tell you what's in progress. So for our sign mounting details, there was some research done a while back. And there's been issues with large signs falling down in the field. So some research showed that if they adjusted the tables, the wind tables, but then through that research, they also removed a couple of the post sizes. So the W10 by 26 and the W6 by 12 were removed. Along those lines of signs falling down, one of the things that we went to the San Angelo sign crew meeting, and along I-10, maybe near Junction, they have a couple of signs where the fuse plate bolts are loosening. So about once a month, they can go out there and they retighten the bolts. So it'd be interesting to know if anyone else has seen that same thing. We'd be interested to know that. We're just still trying to figure out, like, will this new standard of larger post, possibly a larger fuse plate, alleviate the issue with the signs falling down? Or is it, I mean, we've seen instances here in the Austin area where you go and look at a sign that fell down and there's a couple of bolts on the ground. So it's like, hey, now there's 3 fuse plates holding up a sign instead of 4. We're going to test out some lock nut washers, is that what they're called? They're lock nuts. They're a certain type of nut that has compression on the backside, and when you put it on, it's not supposed to release. So we're going to test those out in San Angelo here soon. We'll let you know what we find out. So as I mentioned, the research developed some new tables for the wind loads, and it'll require a larger sign. On the SMD type G, that sheet was removed. And then the SMD 8W108 was also removed, but it was replaced by the SMD LRSS standards. And then, so we updated our maximum spacing tables as well. And I don't remember what's here. So we also have different splits. So the old one was just the 54-46% split. So now we have an option for a 60%, 40% split. And we removed the sign walkway and lighting bracket details because no one's using those anymore. On the monotube sheets, we removed sheet 3 and we incorporated that information on the sign mounting details 2-6. So everything's been relocated there. We came up with some new sign summary of large signs for ground mounted signs, overhead signs, and removal signs. So hopefully, for those of y'all that are designers, hopefully that helps y'all out. For those that are doing construction, having stuff separate and the district's not having to make their own, hopefully that's helpful to y'all. And so some of the standards that were removed, the mercury vapor sign lighting fixture, sign lighting electrical details. I mentioned that the sign walkway and handrail information was removed. And then the support bracket for signs, walkways and lights was also removed. High mast illumination, standard was updated. We moved from a single 12 light configuration to multiple configurations. Hopefully y'all have seen that and already been using it. We consolidated some notes that were contained on sheet 7, 8, and 9 into the new sheet 7. And we moved a lot of that information over to a department material specification so that if updates need to be made, those updates can be made a lot easier. And so some of the standards that we're still working on, our sign mounting details. There's a couple of things that were just little hurdles. There's one little hurdle on that we're trying to get over. It's going to change the way, I think that's kind of maybe not really related to y'all, but then still working on the roadside flashing beacon assembly and solar powered roadside flashing beacon assembly. We're updating the typical signing requirement standards, electrical details, high mast illumination poles, high mast illumination foundations, and then OSB and the cost structures. I wanted to, I think everyone knows the new spec book just came out. It's very beautiful colors, maroon and white. We received copies on Monday. I looked at the website. It still didn't have the information of how to purchase those. So be on the lookout for that, for those to become available. And then just wanted to share something else that when we were, and I'm going to give a little presentation after this on like the specification changes, but when you go to the specifications page, up towards the top, there's a link for 2024 specs. And then at the bottom of that page is this section here of additional resources. And then this last link, specification changes, has, and if you want to scan, yeah, you should be able to scan that QR code. There's red lines there. So if you're curious what changed from 2014 to 2024, there's red lines there. There's also the presentation that we gave back at the different AGC presentations. So there's just some useful information there that y'all might find useful. And then if you're really bored, you could watch a video of me doing the presentation. All right.
All right, so now we'll go over some of the stuff from the bridge or the structures perspective of it. So, like I said, there's been a lot of things in the works. So a lot of the same kind of, we're working on getting these things out. This is kind of a snapshot of exactly what it is and different things that we're updating from a specification standpoint. So our main goal right now is to get anything that's designed under the LTS 3 standard spec, which is really before the fatigue provisions were in place, getting that up to the LTS 6 or the LRFD. Anything that was in the works and the majority of it is done, we're updating to the LTS 6. So that includes the high mast illumination poles. Like to say we're almost there. The design is done. We're updating the last bit of the sheets and then it goes through internal review and then it'll get sent out for the external review again. It was sent out for external review about 10 years ago. I figured that's been long enough. We're going to send it out again and get comments back again and just act like it's a new 95%. Some of the other things that we're kind of looking into is we're starting up the roadway illumination assembly update. Since we are updating that, we will be going to the LRFD. One of the other things we're looking at updating that for is to take it up to the 50-foot height. Right now, the standard is 25-foot height. We did have some requests from districts about, well, if I'm putting this on a direct connector or something like that, 25 feet isn't really high enough.
That's
the base of it, yeah. Yes. The overhead sign structures, so this OSB and the costs. We did get the 95% plans from the consultant, so then there's going to be some in processing and stuff like that. But that is also moving along. Right now, the monotube sign structures is not in the immediate future for updates. It's not that we won't be updating it, but I also don't want to come here and go, yes, in 5 years we'll start updating it. It's to a specification that is current. It's got the fatigue loading in there. There's other aspects for us to look into there. We only have the 24-inch diameter, and then we're limited to the 3/4 inch pipe thickness. So we removed the ones that had the thickness over 3/4 of an inch. For us to get kind of the spans back, we're going to have to look at increasing the diameter of the pipe. So it's going to have to be more variable than what we have right now for us to accommodate some of those longer spans. We are looking at the traffic signal poles. That is taking priority over, say, the monotubes, because we are at the LTS 6. There were some updates due to research for the fatigue stuff, but we are looking into those in depth and taking it to the LRFD since we are starting that. We do have the wind and ice maps for the LRFD. To reduce confusion, we're not posting them until the OSB and the COS standards update. However, if you are, for the designers, if you're doing a one-off design and you're using the LRFD, reach out. We can send you those maps. It's just I don't want to post a wind map and then say, yeah, but it's not used on any of these standards. So that's where we are with that. Some of the other details that we are responsible for are the DMS attachments, the connection between the concrete column and the truss support. That is on the last round of review before it gets pushed through the formal review cycle to all the different divisions internally and then externally for the 95% review. The bridge railing mount, that's at LTS 6, so I don't have any immediate plans for that one right now since it is a current specification. The sign mounting details, the idea is to get, and that's the connection, right? That's the sign to the trusses, right? And so we're looking at updating that when we update the OSB and the cost. So it says it's LTS 3 right now. It is in the works to be up to LRFD as we move forward. So those are really kind of the updates as far as our standards and what we've been working on. And we have been moving multiple things forward. But we are working on a lot of different things trying to get that specification up to be current. So with that, I will turn it over to Mark for updates on maintenance.
All right, good morning, everyone. Mark Johnson in the Maintenance Division. I don't have standard sheet updates. We don't generally do the structural standards in Maintenance Division, so I figured I could do a little bit of an update on some data that we have. This may not be tremendously exciting, but what I try to do is go back over the last 12 months of rolling data, looking at bid item usage in our internal system Site Manager. And so I really focused in on items I think that are related to this group in TASIG for structural elements. You can see here in the last 12 months, and this is, to be clear, specifically related to routine maintenance contracts. This is not construction projects. If this were construction project data, these numbers would be substantially higher. So really just kind of looking at, from a maintenance perspective on routine maintenance contracts, what kind of work we've been doing in this realm. Focusing on three main areas: illumination, sign work, and traffic signals. Don't have a lot of data related to ITS. Most of our ITS work is done through purchase of service contracts. However, to be honest with you on those, I've seen some of those contracts. Most of that work, it tends to be more troubleshooting, trying to figure out why we can't talk to a cell modem or having issues with a fiber line, things like that. So we do repairs of fiber lines, repairing radios. Sometimes it's simple things like flipping breakers on closed circuit television cameras. So this data is really more focused on the other three main pillars in traffic, which would be the luminaires, traffic signals and the signs. You can see here on the left side, the winner, I guess you could say, in terms of the cost is the illumination pole maintenance. However, a lot of that work tends to be more LED upgrades. We're still in the process of doing that statewide, and there's substantial data that reflects that we are continuing to move in that direction of a much cleaner light source. We're consumes much less energy than the old high pressure sodium light bulbs that we typically used to use. In the last 12 months, we ran down about $4.3 million worth of work here. However, this was kind of a quick and dirty exercise looking at bid item data. So some of that bid item probably could have been thrown out. It may have been more just flipping out the bulb, changing from high pressure sodium to LED. So I think that this number may actually be a little bit high. And you can see $4.3 million in the last 12 months is really not that much money. In particular, when we look at our maintenance budget, so we get appropriated through the legislature. In this past legislative cycle, we increased our budget from 1.3 to 1.6 billion. That was very substantial. You can see something like 15–20% increase. However, in reality, I think the actual amount of work being done isn't a whole lot more than what it was. A lot of that was really responding to all the inflation that we had to deal with, particularly the year after COVID or so, when it was really, really bad. We were not able to do nearly as much work with the same amount of money that we had. So we did get an increase in budget from the legislature, and that's kind of reflected here. We will be also in moving this forward in FY25. We're going to have a similar budget around 1.6 billion, and we are probably going to the legislature here shortly to request even more funding for the next biennium for our statewide routine maintenance budget. The overhead sign structure work. So if I go back to the previous slide, you can see here, this is kind of a larger bar slice here, over $800,000. When I dug into that a little bit more, whoops. Okay, sorry. When I dug into that a little bit closer, you can see here that this is really work done on 4 contracts in only 3 districts in Dallas, Houston, and Waco. I didn't dig into it too much deeper than that. If anybody wants more detailed information on those contracts, I can be glad to look into that and provide that to you. I don't know if those are blanket upgrades or what they're doing, if they're replacing structures that may have been hit. The drill shaft work here, this is the item 416. So we use these for traffic signals, we use these for luminaires, we use these for sign structures. So that pay item would really across all 3 of those pillars. Looking at the data more closely, my observation was most of that was related to sign mounts. I saw both overhead signs and roadside large sign structures. I think Ralph already talked some of the work that's been going on there with the standards. It did appear to me that a lot of the large roadside sign work and the luminaire work was new install. So new signs, new luminaires. Somewhat interesting on a maintenance contract, you would typically expect that to be replacements, luminaire poles that got hit, large signs that may have been hit or even blown over. The bid item data didn't necessarily reflect that. However, there could be some issues there where maybe we are not necessarily using the correct pay item. And then when it came to the high mast poles here, and again, I'll go back real quick. We don't have a ton of cost there, something like $200,000, very minimal. And even that in and of itself, I could see was only on 2 different contracts, only a couple of instances where we installed high mast poles on routine maintenance contracts. Probably at this point, 98% of that kind of work is happening on a roadway construction contract. So all that to be said is, well less than 1% of our overall statewide routine maintenance budget is in ancillary structures for traffic. Not a huge percentage of the cost, but that said, my general observation is that probably a lot of that work is related to large roadside signs. I don't know specifically why the bid items are for new signs. Potentially they're getting requests where these are needed. We just used a routine maintenance on-call contract to go out and install a sign that was needed. Surprisingly, I just didn't see a ton of data in our bid item data that reflected these were replacements for signs that were either hit or knocked over from wind or something to that extent. All right, questions on any of that?
All right. So last year we did mention something about a contract for HMIP and cost structures. And so Greg Jones is here to kind of present on some of that data.
Right. My name is Greg Jones with Traffic Division, and I'm my group. We handle lighting. We do standards and specifications and practices. statewide for the districts to use. And in 2020, we started a contract with the Michael Baker International to inventory traffic structures and inspect them and to develop a database. Guys, but before that time, you know, I deal with lighting. I deal with high mast poles. So I said, we're putting in high mast poles all the time. We don't know how many are out there. We don't know the condition of them. Some of them have been out there since the 70s. So we need to, you know, find out what we have out there and get an inspection program going. So we started that contract in 2020. First couple of years, we looked at high mast poles, and then in 2022 there was a cantilever overhead sign structure on US 75 in the Dallas district that fell into traffic. So then we also included overhead sign structures too. So this is a 5-year contract. We're in the 4th year right now, and it's got 3 parts to it. There's an inventory part where we get our inventory with a LiDAR truck. So the LiDAR truck basically just drives through the roadway, and they can get all kinds of information. They get the location. They can get dimensional data, like for a high mast pole. They can tell what the height is. They can tell how many sections it has. They can tell how many sides the pole has. They can tell if it has a ground sleeve at the base plate or not. So we get a lot of information just from the LiDAR truck. And then also for like sign structures, they can get, you know, the span length and the clearance over the roadway. Then we also do part of the contract is inspection, and it's a structural inspection. So we're inspecting things like the anchor bolts, the welds, the base plate, the foundations, the galvanizing condition, and then for the overhead structures, they also go up there and inspect with a bucket truck and inspect the upper structure. We don't have enough funds to inspect everything, but we do expect pretty good sampling of the structure. And then the third part is the database, which I think is a really good way just to keep track of all the inventory and the inspection info. So currently, our database, this is our portal. It currently lives on the Michael Baker site, but it's because it's still being developed. But then eventually, that's going to probably next year sometime. It's going to come over to the TxDOT system, and then we'll have easier access to it. So I'm just going to kind of show you some of the things that we can do with this site. We have a MS structure tab, and then a sign structure tab. So for the high mass, we've covered all of pretty much all of Texas except for the central West Texas part. And these points in blue are the high mass structures. So in Texas, we have 6,000 or so far. There'll probably be a few more once we get West Texas. And then we inspected about a fourth of them. But if we we can zoom into a district. So let's say Waco. So in Waco, we have 60 high mass structures, and we can look at 150-foot poles right there, or we can look at, there's just a few 175-foot poles up here by the split. And then I made this into good. Let's try a different district. Let's try Fort Worth. Yeah, we could also see the number of sides in the pole. So we click on here, get 12-sided poles, or these are the 8-sided poles. And you know, if you want to see what, you know, show me the 12-sided poles with that are 175 foot tall, then we can you know, drill down into that. And then Yeah, let's zoom in on, we can zoom in on individual pole. So here's the actual inspection report, which, and it also has like a link to the pole in Google Maps, so we can see it right there. And if we okay, yeah, we can see the different, yeah, we can see the different parts of the inspection, you know, the anchor bolts, the column support, the foundation. And then also we can actually look at the actual inspection report for that individual pole. So here's their evaluation of all the parts. We got pictures of each part of the pole. And so it's just a good way to find information on a specific pole you're looking for. Then also we have our sign structure tab. We kind of covered the same area. Notice that like Houston and Bryan and Lufkin don't have data yet. We've got the data, but it's hasn't been extracted yet. But so not including Houston, so far we've got 8,000 overhead sign structures. We've inspected 732 of them, mainly just the Dallas-Fort Worth district is our inspections. But then, so we can, let's see if we, zoom into Dallas here. So in Dallas, we got 2,400 sign structures, and then for spans, these are the sign bridges. These are the cantilever, these are the butterfly, and then there's a few bridge mount signs right there. And in the same way, we can zoom in, pick a pole. There it is. And we can, you know, see the, you know, there's the Google map for it. We also, you can also pull up the LiDAR data, and we can pull up the inspection report. Also we're also including the statewide cost structure anchor bolt inspection that's TxDOT did, all the districts did back after that sign bridge, after that cost structure fell. And so we've got all the different parts of the sign bridge that they've inspected, you know, the connection to the structure, looking at the galvanizing right there. So this is still being developed, but it's if anyone's interested in access to this while it's being constructed, we can get access for TxDOT. I'm not sure about people outside TxDOT, but if you're interested in having access to this data, let me know. I think this will be good for districts to use for maintenance. They can look and see, they can check on the status of their of which poles you know, need work, and or they can also check on you know, design issues. For example, there's an issue with high mast poles, 150-foot high mast poles that do not have ground sleeves. So we could go in here and we could find those specific poles more easily. So that's about it. Any questions? All right, thanks.
Thank you, Greg. That was interesting. I like the idea of having all this information at kind of your fingertips and actually having an idea of where things are, especially the high mast illumination poles that don't have ground sleeves. I'll be getting with you later. We can talk about that. So The next presentation we have is going to be the updates to the 2024 specification. Raphael will be back up here. Let me get that.
All right, so I took the presentation that I did at the AGC and whittled out the items that didn't apply. There still may be a couple in here that don't apply, but they seem to kind of fit in a little bit. All right, so item 610. So I'm just going to highlight the things that changed. So item 610, roadway illumination assemblies in the materials section, there was a new note that was added. Provide punch, drilled, or mechanically guided thermal cut holes in steel parts or members when allowed before galvanizing. You'll see that come up again on one of the other items. In the construction section, sampling fixtures for testing in accordance with text method 1110-T was removed. When you're relocating an assembly, there was a little note that said added clean optical assembly when reusing. And then replace luminaires, added replace conductors and breakaway fuse holders when necessary. Item 613, high mast illumination poles. In the fabrication section under construction, they added ultrasonic testing of seam welds. They added that same note that I just read earlier. And then added perform ultrasonic testing of base plate weld joint after galvanizing to determine if any toe cracks are present. And then item 614, high mast illumination assemblies. In the description, added a new item for replacing luminaires, just the light fixtures. And then in the materials section, they added the word LED. It used to just say high mast light fixtures. Now we're using LED, so that was added. And then in the construction installation section, so those of y'all that deal with this may know what this is, but they added the highlighted section. So modify assembly, ring halves, and support assembly in the shop to ensure proper fit and mark the ring halves and support assembly before shipping. So the highlighted section was added. Continuing here with high mast illumination assemblies, for replace luminaires, they added instructions in the construction measurement and payment section for that. Item 616, performance of testing of lighting systems. In the past, it used to, I think, have to wait till the end of the contract. You have to maintain it that whole time. Now, after the lighting system is installed, contractor just has to pass a 14-day performance test before turning maintenance over to the department. For temporary roadway illumination, it's kind of one of those ones, not sure if this is really TASIG related, but in the description, measurement and payment was changed to setup and removal and maintain roadway illumination. So setup and removal is measured by each roadway illumination assembly installed and removed, and a relocation is considered an instance of setup and removal. Maintained roadway illumination is measured by the month and covers maintenance of the complete system. And in the payment section, electrical service responsibilities were changed to match that of item 681, temporary traffic signals. Item 647, large roadside sign supports and assemblies. In the description, added replace existing large roadside assemblies that they weren't using in Mark's contract. I don't know why, but in construction, they deleted the following text at the contractor's option. Sign supports may be cast in concrete foundation as a unit. However, if installation is made, and then in 3.3 relocation, I have a little thing in my way here. They deleted the bolded section. So you can reuse the supports and you can shorten them, but you cannot lengthen them. Item 650, overhead sign supports. In the materials, they added item 420, concrete substructures. I guess that wasn't there before. And then in the alternate design, they added wording to require cost plan and elevation sheets, and other sheets necessary to support design calculations. And then they just changed some wording, the size of pipe to pipe diameter and wall thickness. In the alternate design, they added tapered columns are permitted if the provided calculations demonstrate that the column is adequate at the level of the truss to column connection. And then in the fabrication section, added details for monotube type overhead sign supports, added text about ultrasonic testing and measuring required dimensions. And then there's a note, shop assembly of monotube sign supports to ensure compliance for all dimensions and fit. Also added. And then that same galvanizing note, provide punched holes before galvanizing. Item 654, sign walkways. It seems like maybe we don't, there's discussion going on now about like, do we need sign walkways for the DMS signs? And one of the things we're hearing is that they're not needed. But nonetheless, there's still some information here about sign walkways, and they added the bolded section that it needs to be, the fabrication plants that produce sign walkways must be approved with DMS 7380. Item 656, foundations for traffic control devices, no major changes. Item 680, I think most of this is more highway traffic signals and not really pole related, but updated wiring guidance. Everything has a certain color that you're supposed to use when it's going to the radar sensors or to whatever item it's going to. Same thing for the railroad preemption. There's a color coding table that was added. And then other information for the cabinet. In the payment section, I don't know if those of y'all are restricted crossing U-turns. So if you have that type of design, the signal cabinets are paid by the each, because sometimes that will require 2 signal cabinets. And then added some information that span wire is paid for under item 625, and signs are paid for under item 636, or if you're using illuminated signs under a special specification. Item 681, temporary traffic signals. The response time was updated to match that of item 680. If there's remote access required, TxDOT will provide the equipment for that and get that set up. And then this picture kind of indicates that I never thought that temporary traffic signals were portable signals, but in the payment section, they added the word portable signal. So there may be an instance where you're not installing temporary signals on wooden poles, but maybe just need something out there or until something gets set up and you need to use a work zone portable signal. Item 682, vehicle and pedestrian signal heads. Added the removal of the signal heads, updated wiring guidance. And then item 685, roadside flashing beacon assemblies, minor changes in language. And in the payment section, you can see there in red, they added batteries and battery box. So it used to just say, provide a battery box, but it didn't say to include the batteries. So that's been clarified. And then item 686, traffic signal pole assemblies, added removal for that and expanded language on the long mast arm assemblies.
So that is the presentations for this morning. At this point, we open it up to open discussion or questions. Sarah, do we have anything online?
Yeah, we just had a comment online about updated wind maps being accepted in the next interim edition. So that's going to be ASCE 7-22. So that's on our radar now.
Thank you for bringing that up. Anybody in the room, any questions or anything about the updates or any of the presentations from this morning, or just any other thoughts on your mind that you really just want to get out there? And The roadway illumination poles? Yes.
Light poles to LRFD.
Yes, so we are going to update the design specification for the roadway illumination poles. There are a few other things in there, like I said, increasing the design height. And since we were going to be touching it and designing it, we figured we'd go forward with LRFD based off of the knowledge that we gained from the cost in the OSB. So one of the reasons why we held off on the LRFD for some of them is because we wanted to see what kind of decisions and how we were going to apply the LRFD specification with the costs in the OSBs before we started applying it to other structures so that we had a solid thought process.
So is that, when you go to LRFD, is that making things bigger or more expensive?
Pending.
Okay.
So it's something that we are starting. We do have, we've created a design example to start from. And so like we're getting into it and developing resources as well at the same time. So we're going to be creating the design example, then we'll be getting into the full design of the standard. So that's something that's picking up right now.
All right, thanks.
All right. So you mentioned about the standard for between the concrete column and the overhead sign. Can you expand on that a little bit? And is there more involved? Is there like column details or shaft details?
So the way that the philosophy that we're coming from on that is that the column design and the column details would be in other sheets. We're really focusing on that connection and kind of the design loading and stuff for the truss and how we want to connect that. There were two options that came up, and we did go through and do the design and detailing for it. And one of them is where you have the concrete, like rectangle, I guess, and then you've got your angles going on it. And then the other one's where you have kind of the round concrete column on top that you kind of set similar to the details that we have for the steel attachment, but you're attaching to concrete. So we've done both of them. The first time when we went through with it, it seemed like the consensus was to do the round column attachment. But as we developed it and got comments back, it seemed like the other one was also of interest. So we went ahead and designed both of them. But the thought is kind of going from the loading of the truss and really just focusing on that connection. And then we've specified limitations of what our assumptions were for the concrete column part, because the height of the column does affect the loading. And so we put those assumptions in there.
Thank you.
I should have put those pictures in. I had them in yesterday. I am very interested to get with Greg Jones after this, though, because I did see there were some anchor bolts that were critical on there too. And exactly what critical versus fair. So yeah, definitely gonna be meeting up with you after this. Not today, but yeah. So, I mean,
Online question here. Any plans to create standards for bridge-mounted OSBs?
so as part of the short answer is no, as far as the bridge details, because that all depends on the bridge and the substructure and where you're placing it. There's a lot of variables there. But for when we're updating the OSB and the cost, we're gonna have the foundation loads. So you don't have to calculate the loads of what our standards are, and you can just take the base loads at the base plate and apply it to your bridge cap. So we're giving you a little bit more information this time around, but I'm not really sure how you would standardize that connection with as many different types of signs and substructures and locations you can put. If you have ideas or suggestions, I will be more than happy to consider it. And again, there's coffee. Everyone's very quiet. I'm not used to this group being quiet. One of the other things, and I just kind of like to get people's opinion on this, is with dampeners, because we have the standard for dampeners for the single mast arms, so up to 48 feet, but we don't have one for the long mast arms. And part of it is, once you get that long, you really need to be designing it for what you've got. Because if you use the really small dampener on it, it could make things worse. So I don't know if anybody has any thoughts on dampeners on these structures or not. Online? I mean, I'd love all kinds of feedback, so I'm more than happy to keep throwing things out there and see what you guys think about them.
We have an online question. I believe Raphael can comment on this. Say a city is building a new road to intersect an existing TxDOT road, and they are planning to widen that in a few years. Can you suggest a temporary setup for traffic signal poles that may be removed once the construction of the TxDOT widening starts? Is wooden strain poles a good option?
I don't design that kind of stuff, so I don't know that answer. It was a city street into a TxDOT roadway that is going to have ultimate signals at the end.
That's what it sounds like. Maybe they're building a road, so they got to put signals in there, but then the plan is to widen within a few years. So what sort of temporary setup would be best
Oh, I
until
see.
they're at the ultimate condition?
Yeah. I've never designed a traffic signal. But I don't know. That's a very good question. I mean, I don't, it depends on you. One time I heard when you're predicting traffic, you never get the number wrong. What you get wrong is the year. So they probably don't know, is it going to be a 5-year fix, a 10-year fix? I think you would just install, regular signals. Maybe you plan on reusing the mast arms or something like that, oversize your mast arms. But I don't know if anyone else has a suggestion, but I think you would just put in a drill shaft and you just have to remove that later. Be my suggestion.
I've seen a lot of them too, where they're using timber poles with span wire temporarily, and they do different phases. Excuse me. I think you said it well. It depends on the duration of the project and how long it's going to be in that state. But if you've got to move poles around quite a bit, that's going to get expensive. You're not going to be able to put in drill shafts.
One of the other things that I'm looking at updating probably sooner rather than later is the steel grades, because I know there's been a lot of questions about using the A500, and as long as we're getting the Sharpie test for it, we don't necessarily have any concerns with that. So that is something else that I'm looking at doing. I figured some of the fabricators would be interested in that information. So I just need to look through all the standards and see every standard that would apply to, because I'd rather kind of incorporate it full scale as opposed to, oh, they're asking about monotubes, let's just add it to monotubes or something like that. So neither am I. Sorry. We have a monitor talking to us, if you did not hear that online. Anything else? We can always go to the break early as well. There's always the open discussion after all these presentations, and it's really kind of free for all for just us all talking and trying to collaborate and work together. One last time, question. All right, well, I guess we'll go ahead and go for our first break. And it'll be a 30-minute break, and we can get back at 10:30, and it'll give us time to just chat and talk to each other. We'll be back at 10:30. On some of the research projects that we've been that have started for the ancillary structures. So please welcome Todd Holle, or Dr.
Thanks, Courtney. I appreciate the opportunity to talk a little bit about a project that started last fall, and actually our student Jung Hoon from UT that's working on it is here. I'd say normally, why don't you get up and talk about it? But I know it's not polite for him to not know what the next slide is going to be, because he gave me stuff yesterday and I kind of tweaked some things. So it's kind of an odd color scheme up here. You rarely see these two colors in the same slide together, but this is a joint study between UT Austin and Texas A&M, and we've done this on a couple of projects, and it's really been working out well. So we have a really good team, we think, from both organizations. But this study is develop assessment and mitigation guidance for ancillary highway structures with existing cracks. So it's definitely obviously related to this interest group, and I think, you know, we're off to a really good start in the first year. If I can kind of get this to forward, there it goes. Just kind of an outline I'm going to talk about is just starting off with some of the research objectives, what we're actually looking at on this study, some of the methodologies that we're dealing with, and two main things on here is it includes both some field assessment as well as laboratory investigations. So those are the areas we've really been targeting over the first year, is the field assessment, and then we're going to be doing some experiments here later this work. Okay. When we look at the research team, we have quite a few individuals involved on this. From the supervisor perspective, there's myself, Matt Hebden, and Salvatore Salamoni. And then, as I mentioned, Jung Hoon in the back here is kind of the primary person at UT Austin that's been focused on this. We also have two postdocs, Aiden Vigeland and Mushtaba is working on this at UT. We also have Chao Yi in the room, who was on this project up until about a month ago, and then TxDOT made her an offer she couldn't refuse, so she ended up coming to work here at TxDOT. So she was also engaged on the study. At A&M, Stefan Hurlebus is a faculty member we've been working a lot with on multiple projects and doing very good work. It's also got Pete Keating and Kinsey Skillen. And I just realized I left Arash off of this slide, which Arash has been Arash Hockney has been doing huge work on this project. So he's also on here, but I accidentally left his name off of the co-PIs. The research assistant, Hangil Kim, is the PhD student over that's been doing a lot of work, and we recently added two new students, Emily and Mike, also to the project. So cast of thousands, and there's two people doing the work roughly. You know, the students are mainly doing it, but anyway, we've got a really good research team. We've actually done a lot in the first year of this study. The scope of this is actually pretty large. It's ancillary structures. So we're looking at this, we're targeting typically traffic signal structures, cantilever overhead sign structures, and then also high mast illumination poles. Really looking a little bit at the potential for cracking and the base plate type connections on here. So looking a little bit at, first of all, getting out and trying to find these cracks, and then what do we do with regards to mitigating them or assessing whether they need to actually have some mitigation done on them. So what we want to try to do is essentially assess some of the levels of damage on some of these different structures around the state. And then some recommendations on that, the cracking. What do you do? How about just monitoring, maybe seeing if the crack is going to grow? Maybe some that you get out and say, okay, we really need to repair this. And there might be some you say, this is kind of beyond repair. Maybe this needs to be replaced, and try to provide some guidance with regards to that. So, and with regards to the repair techniques, what do we actually do? Okay, what should be done to actually repair some of these welds? Also, some of this is trying to get out and find these cracks. It'll kind of show a little bit that the cracks out there, usually a lot of times they're not visible by eye, which means you need to be able to go out there and actually be able to have an inspection technique to can actually find some of those cracks. And some of that is just trying to train individuals to be able to find some of these. They can be actually somewhat difficult, which is something also that we're working at on this study. I think a lot of you may be aware a little bit of where some of the cracking happens. Some of it happens just while it's in service, where you have some wind loads and so on that actually crack on the sections. But in a lot of these, and I'll focus primarily on high mast illumination poles, we've done a lot of work over the last 15 or 20 years, and we've learned that a lot of that cracking actually happens during the fabrication process. You know, you take this, and we want to make sure that these poles have a long life, so we tend to galvanize them to improve their corrosion performance. But we found out with the high mast illumination poles, it was during this galvanizing process where you dip these into the bath, and the geometry of the poles, particularly for high mast illumination poles, you have this humongous base plate, can be anywhere from 2.5 to 3.5 inches thick in some cases. And then I'd get this very thin wall of the pole, which may be 5/16 of an inch in some situations. We did research on this about 12, 13 years ago, where we actually went up to Sabre, galvanizing plant up south of Dallas. We instrumented some pole sections where we would drill holes in the poles, put some thermal couples in there as well as some strain gauges. When you lower these into the galvanizing bath, the wall of the pole heats up immediately. Like you would just see a spike where it went from, 70 degrees up to, 800 degrees in a matter of seconds. The base plate's not like that. It takes minutes for it to actually heat up. As these heat up, the wall of the pole expands very quickly. It puts a lot of stress on that weld, and that's where the cracks tend to come. Okay? We found actually on some of these, and there'd been some work done in Europe that kind of pointed out the same thing, that the propensity for cracking, if you end up looking at the diameter of the pole to the wall thickness, if it was greater than 70, it tended to crack. If it was less than 70, it didn't. So, some of this could be controlled a little bit with geometry. I'll kind of mention a little bit later that a lot of times the detail of interest for high mass poles is to use the ground sleeve, okay? Because that also had reasonable things. And I'll actually call into question a little bit. It says, I don't know if that's the best detail we should be using, but I can kind of throw that bomb out at the end. We can kind of talk a little bit about it potentially. It's not really the focus of this study, but it is something that TxDOT may want to consider. We've done a lot of research actually even on these poles and so on, looking at the behavior, a lot of field monitoring. A couple of different studies have done this where we've gone out, put some strain gauges on the poles, put some anemometers and so on to look at wind speeds and things on up the pole and kind of look at the behavior that we ended up having on some of this. We instrumented poles all throughout Texas, some in central Texas, some up in Dallas, some on the coast, some up in the panhandle and so on, just to look at variations in wind and so on and what they end up causing some of the potential for the cracks to actually increase. Okay? We did lots of laboratory tests on these where we would take, and if you have a pole section, you want to end up having the cracks actually grow. We would end up putting cyclic loading on these and then kind of subject them to load so that the cracks would actually start to kind of grow and kind of look at some of the inspection behavior. As I mentioned, a lot of times the cracking that you end up seeing, it's not visible by eye. So historically, what we used a lot of times, what we call just conventional ultrasonic inspection techniques, where you kind of take and you could actually find some of those poles, but it's the cracks in the poles. But it was actually hard to actually locate some of those. By the time you can see it, like as we see in this slide, where you can kind of see some of the cracking over here, usually the fatigue life is greatly diminished to the point where, well, if you can see it, you have a major problem, you need to move quickly, okay? But things have changed a little bit from the inspection techniques that were used and so on. And we did it, the studies we did about maybe 12 or 13 years ago, we took a pole out of service from El Paso and brought it into the laboratory and did so much of testing. And we also worked with a contractor from up in the DFW area that had done a lot of the field assessment on these. What we ended up doing in this case, we were characterizing the cracks. Once we knew what the cracking was, you'd take, as far as repair, you'd grind some of that crack. And by the way, I can't just say just grind. It's you grind and then you grind some more and then you grind some more, because you've got to kind of get in there and you're trying to get down to where you get rid of the crack totally. So we're usually using like a mag particle to kind of find it where you got rid of the crack. And then once that would happen, you could end up doing the weld repair and get this back to where it wasn't really, it's no longer cracking on that section there. What was done actually during that stage, their repair process was actually they're using ultrasonic impact treatment, which was actually relatively expensive. The equipment's, pretty specialized. I don't think it's necessarily required. So one of the things I'm looking at is, do you even need something like that? You're just trying to get rid of the cracks and get back to the state where this is in a nice case. So whether or not you need this ultrasonic impact treatment, but by the way, what this does, it comes from like the aircraft industry and so on, where you go into welds, you take this impact treatment, you can actually put pre-compression around the weld toe and so on, and even get much better behavior out of it from a fatigue performance. But it is a time-consuming process, and whether or not you have to have it. So we may look at it and say, well, no, you don't really need to do something like that as far as the repair procedure. It kind of just a lot of background information up this point. When we end up looking at this project, it's divided up into 11 tasks. I'm not going to focus on each of these. We'll kind of focus a little bit on the ones we've really been working on lately. One is the field assessment, trying to go out and look at what's out in the field as far as the traffic signal structures, cantilever overhead sign structures, high mass, and get a feel for the level of damage that's out there right now. A major part of this is going to be some laboratory experiments. doing tests on traffic signal structures, costs, as well as HMIPs, and then also trying to develop some of that evaluation of the weld repair techniques that may need to be done, and then, provide some guidance essentially for what we're doing. Okay. So again, we've kind of tried to go out already and do a little bit of see what's out there in the field on some of these, and then look a little bit, hopefully in the next year and a half about what's going on in the laboratory, what's going to happen with the weld repair. The last year, we've done significant amounts on the field assessment for the different structural systems that we end up having. What was happening about 10, 12 years ago, TxDOT had, many of you know, VJ would work for TxDOT, and the VJ was just a magician as far as to be able to go out and find the crack, but he was usually typically conventional ultrasonic testing, which you kind of found out that it was more of an art, in my opinion, rather than a science. Phased array is a relatively new technique. When you look over the last 10, 12 years, it's become maybe the primary way that we assess these. I'm not an expert on it, but we do have, like, Stefan Hurlebus has done a lot on this. Salvatore Salamoni at the University of Texas has been very good. Jung Hoon has become an expert on phased array techniques, but it allows us to get out and do a much better assessment, really, of the defects and so on that are there. So what we've spent over the last year was, again, improving our abilities to find some of these defects and then get out and try to look at what's out in the field. What happens on a lot of these, though, is in order to see, am I good enough to do this, is you need to have something where you know that there is a defect and so on. So one of the things we did on this project, there's a company out there called FlawTech that'll actually make little specimens and so on that have known defects, and they'll tell you where they are and how big they are, and you can actually see, can we actually find those? One of the things we're actually hoping to do from this project is our plan is to actually try to provide TxDOT potentially with some specimens, high mass, costs, TSSIs, that traffic signal structures that you can actually use potentially if you want to take your inspectors and say, hey, you should be able to find these defects. Okay, so what's nice about our laboratory tests is that we can kind of get in and really characterize what's actually there. And actually, I remember this a little bit that we were working with some stuff with VJ at the time, and they were doing some things on some high mass poles where we knew there were some cracks because he already had found them, and he went out and he looked again and says, I can't find them. And you find out, well, the sun was shining on a certain side of the pole and it made it bend a certain way, and the crack suddenly closes, and then it's harder to find. So we want to be able to a little bit get in and be able to find, produce some specimens that you can actually use for somebody to go in and say, I should be able to find some of these cracks. That's one of the things we're kind of hoping to do. So instead of using the smaller specimens, actually get something that's going to be more like what's actually in the field that your inspectors actually need to be able to find. Our field assessment is part of the contract. What we had proposed is to try to go to a few different regions of Texas and sample the structures that are out there to see what we actually have. So the places we had proposed are Dallas, Austin, Bryan, and Houston. You may be able to figure out why we picked Austin and Bryan, that didn't have to travel too far, but also when we look at Dallas, we look at Houston, they're big metro areas. They have very different wind conditions and so on for like high mass poles and cantilever sign structures. So they give us a pretty good sampling of what we have. What we proposed was in each location to take 10 traffic signal structures, 10 cost structures, and 10 high mass poles, and try to characterize what's going on in some of those. These were essentially more of a random sampling. Some of them were more of like, we'd go up, and I actually told Jung Hoon and so on when they're going out, says, if you get out there and it doesn't look safe, then that pole's not worth looking at. So try to find ones that actually we can get in. We don't have to really worry too much about traffic and so on. But we were able to pick out the poles, and we've actually completed the assessment in all 4 of these regions. So we've got about 120 different structures where we've got a pretty good indication of what we've got on those structures. So we can kind of go in and look, like if we look at the costs type poles, we're trying to look now at the best way to present the data that we have. So we're looking down on the pole section, you can kind of see here, and then kind of we got the traffic arm, or not necessarily traffic arm, in this case, the sign arm that's going to be on there. And try to at least look and see statistically on the poles we looked at, is there a particular region where the cracks are most prone? So what we've kind of found a lot of times, if we look at the gravity-induced stresses that happen from the overhead sign structure, whether we look at the tension side or compression side, and you find out, well, a lot of the cracking, we found a higher percentage more on the far side, away from the traffic, because that's again kind of where from gravity, that's what we call it the tension side on the structure. But what we can do using the phased array is kind of get in and look at the location, the length of the crack, and potentially even a little bit of the depth of that crack that we end up having on some of those. We see a similar type of behavior from the traffic signal structures, that when we start looking at, again, the gravity-induced stress, kind of from the traffic signal. So whether it's the tension side or compression side, not quite as much of an indicator on those as we saw like on the cost, at least to date as we're looking at some of that structure, but it does provide a little bit of an indication of the behavior. I will mention a little bit from an inspection perspective, when I start getting to a high mast pole or a cost structure compared to a traffic signal structure, inspecting everything around the base is not quite as time consuming because it's a smaller circumference. You get to a high mast pole and you're looking at feet of weld by the time you do your 2PIR type calculation. So again, a little bit more guidance on look here and really focus on this area is what we're hoping to provide. We can't provide that, and we have to say you have to kind of inspect the whole weld system. When we end up looking at the high mast illumination pole, there isn't like some gravity cantilever arm, but what you usually have in a lot of these poles, we actually found this on some of our past studies, is that a lot of times, depending on the pole location, there is a predominant wind direction that dominates throughout the year. 20 years ago, we thought like some of the propensity of the cracks to actually grow were caused by like maybe buffeting during a windstorm. And then you find out, no, a lot of it's actually caused more by vortex shedding. During a windstorm, we have a certain number of those throughout the year, and may have larger stresses. But what we kind of found with a lot of these is that there's a little sweet spot as far as like where it sets up a resonance in these poles. It's usually around 6 or 7 miles per hour, okay, which is like always, that these things are going. And, you can end up finding that the stresses are extremely small, but you're looking at millions and millions and millions of cycles potentially. So like our last study we did in our laboratory, we were looking at the fatigue performance of these at the really lower stress range and what ends up happening on it. But from that perspective, you find that, the distribution of our cracks, and what we're finding is some of these have a ground sleeve, some of them don't. We're looking at whether or not the cracks occur at the base, whether they occur at the ground sleeve, and kind of what we end up having. So again, we've done all the field assessment. We've got the data. We're still trying to look at the best way to present all of that data in an efficient manner, because we don't want to provide necessarily, gee, here, look at 120 distributions, and instead looking more statistically, okay, on cost structures, here's what you might have, and try to minimize that down, on what we have. So A&M has taken about half the poles and so on. We've taken about half, and we're trying to combine both of those systems. So this kind of summarizes what we found to date. This may change a little bit as we kind of look more at the data as the region, where the cracks that we've identified, where they're occurring, and so on the structures we've done. I mentioned another major part of this is laboratory experiments. We want to look at all 3 different types of structures: high mast poles, traffic signal structures, and cantilever overhead sign structures. The lab tests are going to use a setup very similar to what we've done in the past. So what we do is we essentially take 2 poles, we put them together, we use what's called a load box in between them. That load box is painted in yellow here. We generally take and we pull up on those, and what that does is essentially we're anchored at the ends of our poles. This would simulate essentially the poles kind of moving and the stresses that might get induced from wind or whatever we have. So when we end up looking at this as we do these tests, it's really the top of the pole that's going to end up getting the damage from the cracking and so on that's going to happen. So a lot of what's nice about this, we can take a single pole, we can do some tests on it, see what happens. If we want to look at repair or whatever we can do, but then we can take and rotate it 90 degrees. Because what happens on this is right at mid-height of the specimen, it's at the neutral axis of bending for the test that we've done. And the bottom is actually in compression. So it's mainly the top of the pole that you put the main damage on during these tests. So we're going to use similar structures, similar tests. Some of the tests we've done at the University of Texas, some of them have done at Texas A&M. So we've got the abilities at both of these to try to get it and look at some of those behavior. The important thing now is getting representative specimens. Okay, so we can design and fabricate them. Ideally, we'd like to take poles that have actually, seen some action service and so on. And we've been very fortunate actually so far. The high mast illumination poles, In one of the situations, the A&M group was handling Houston for the field assessment, and Stefan Hurlebus and the team were out there, and they were going by Beltway 8, and they noticed some poles were being taken down. So they stopped and talked to the contractor, and we were able to get, we actually asked for 2, but there was some miscommunication. The contractor sent one of them to the salvage yard, but we were able to get one of them that they picked up. So I actually contacted David here and said, hey, if we can get any other poles, if you know of any other ones that are happening, it'd be very, very useful for us to get that. Well, David found there were some over in Dickinson, right on I-45, that they were also taking down. So we were able to get 3 poles actually from that region there. It's nice. These are poles that have been in service for a while, so they already are going to be representative of what's out there in the inventory. So that's actually good. But you find a little bit of this, that the contract, TxDOT has to usually go to a contractor and say, hey, you take the poles down, they belong to you, you do what you want. So we've had to do a little bit of the meet in the back alley and hand a wad of cash, you know, and I don't want to fault the contractor, because the contractor's like, look, we load these on a truck, take them to the salvage yard, they hand us cash. We don't want to do something special or anything like that. So, but we've been able to actually work that out. So we've got 3 poles on the high mast side that are now at our laboratory. They show a couple of them. Here's the one that Stefan and his group got. It does have a ground sleeve. You don't see a lot of the shape of the base plates necessarily that we have there. But anyway, one of them has a ground sleeve. The 3 that we got from Dickinson do not have ground sleeves. Okay, so we've got kind of a good mixture of geometries and so on the high mast poles that we'll actually be testing. On the traffic signal specimens, Stefan and his group actually have another project also looking at the behavior, and he's actually found a number of traffic signal structure poles from around the state. So he actually was going to say, well, we'll take 2 of those and we'll end up using them for our test. In addition, we're designing a couple of new ones. So we're going to have 4 total specimens that we think we'll actually be using there. The 2 that we're getting from the field have similar geometries. But when we look at it, one of them is a multi-sided specimen. The other one is a round specimen. So again, a little bit of the representative geometries that you might find out in the field from those specimens. These show actually the specimens that we've actually designed and are going to have fabricated. We think it's going to be from Belmont. We've been kind of jumping through hoops trying to get these. We originally went and got a quote from Belmont in June, and they said, well, it'll be 12 to 16 weeks until we can get that to you. And, you know, in the research community, you guys are used to that. In the research community, we're like, we need it tomorrow. Is that too early? So then we tried to work with a contractor up in Dallas to see if they could, because they said, oh, we can do it in a few weeks or something. But there was some miscommunication. So now we're back waiting for Belmont. So we're hoping to get the new specimens sometime this fall from there. This kind of shows, again, the geometry of what we've designed and what we're going to end up having. You know, when we look at this, we've got a base plate, and then we put an end plate that we just kind of use to kind of connect into our test setup. We still also want to get some cost specimens. Okay, likely at this stage, I'm assuming we're going to have them fabricated. But if any of you know of any cantilever overhead sign structures that are being taken down, you know, please call us, because we would like to get access to things that are actually out in the field already, because again, they have the better likelihood that they're already going to have the damage that might end up having kind of on some of those systems. But anyway, we're in the process of designing. We'll probably get some quotes in the next few months, but if we can find some in the field, we would rather have those because we think they're a lot better. So just kind of summarize where we're at. We've done all the field assessment of the 3 different pole types, given us some pretty good indications and so on of what's out there, the type of cracking and so on that we're going to end up having, or that are going to be existing in poles around the state. We've gotten high mass illumination pole specimens as well as traffic signal structures. We still would like to try to get some cost specimens from the field. If not, we'll have them fabricated later. The research team has become pretty proficient at phased array techniques. We actually think, though, that, you know, again, we're going to get better at this as we start getting in the laboratory, because what's nice about in the laboratory is we can kind of go in and say, okay, here's where we're finding cracks, and here's where we think the cracks end. When we actually put them into a setup, we can actually see, is that really what happens? Because when we pull up on them, it tends to open the crack and it becomes a lot more visible, you know, with the inspection technique. So it'll let us know a little bit about what the resolution of the phased array technique is in an unstressed pole versus a stressed condition. That'll actually be pretty important for us to understand a little bit about what we're going to end up having. So the experiments, they're going to be underway in the coming months. We're working right now on the setups, and we hope to kind of be kind of moving in that direction. I'll be happy to answer any questions on this. The last thing I wanted to kind of just point out, we're talking about new standards and stuff that's going to happen. And again, some of this is my ignorance potentially. I was asking David, right now, like for high mast poles, we think, what my recollection was 10 years ago, okay, we're just going to put ground sleeves on everything. I had a long talk with Carl McKetta Carl McKetta works for Valmont. He's not in Texas, but he's one of the best experts probably in ancillary structures from a fabrication perspective and so on. And had a lot of talk with him about, first of all, the specimens we wanted to get fabricated from Valmont. But also he had said that he just hates the detail that we use here with these. He said it's so expensive, the ground sleeve, because you're cutting, you're welding, it's increasing the amount of welds. And, and I'll throw out what we had decided like 10, 12 years ago is that a good source of potentially eliminating that cracking during the fabrication process is use a thicker wall thickness. And if you take that the effective pole diameter of the wall thickness, if you keep it below 70, you didn't get that cracking. And frankly, it's a lot cleaner connection. I understand with the ground sleeve that you have, more thicker section, more that maybe you get better cracking, but it is also a messier connection. So it might be something just to think a little bit about it. And by the way, you're not increasing the wall thickness in the high mast pole the entire length. It's the base section. If you want to stick with a 5/16 inch wall thickness for the upper tiers, you still could do that. But it's just something to consider about. I've kind of been outside of the ancillary structure life for the last 10 years because researchers, we have a very short attention span. Oh, there's no more funding there, so we move to something else. So anyway, but that's kind of something I would suggest you think a little bit about. Granted, from an inspection perspective, you need to be able to look at, ground sleeve sections, non-ground sleeve, but if potentially you get simpler structures out for the new ones you're putting out there that still have very good performance, it may be something to think a little bit about. Okay. And anyway, I don't know how I did on time, but it was still 25 minutes, so I think I'm doing okay. But if there's time for questions, I'll be happy to answer anything that we've got. If you have any really difficult questions, I'll ask John Hoon to answer them. I know all the answers to them, but I just want to make sure he gets the opportunity. So. Okay.
Hey, Dr. Hellwig, thanks for being here. I just have a question that Raphael mentioned. The standards are updated like for removal of sign structures. So maybe there's a way to use the TxDOT bid items and the database there on, projects that are coming out now and seeing, I don't know if there's a way to flag that and see any COSs that are getting removed like today or next week or something. But there's a bunch. I mean, I don't know how your data works, but there's a spec item for that, and there's a bit, there's a bid item for that. So he was just talking about the sheets for those removal items. Then I had a question about the causes also, because you showed a picture about the gravity loads and how on the tensile side, but on the causes, the wind is far more significant than the gravity
you're exactly
load. So
right.
that is it all the way around? I don't know if that.
We're inspecting everything, but we're just trying to say where are the cracks that we're finding. And when you look at the cost, it's you've got wind it's hitting the sign that's putting torsion on it. You've got some bouncing because there's a little bit of a galloping that ends up happening as the pole is there. But we're trying to look at this a little bit. Like one of the things we can always provide as a guidance to say, well, here's where the traffic is running. Here's where the sign is. If an inspector is able to go out there and kind of say, okay, I'm going to inspect most of the base load, but I really want to focus on this region. We want to try to provide that guidance. Because again, this stuff visually you can't see it, so you've got to get in and inspect the whole thing. But we're just trying to make a note of here's where we're seeing most of the cracking. Because if you can find that, then an inspector can go out there and say, okay, I'm going to sample kind of in this region, but I'm really going to check this other region over here. And then that's all we're trying to do on it.
Yep. I just was thinking your diagram of what the gravity loads did because of the wind on it. I mean, you're going to see both sides of the causes are harder to zoom in on where maybe the problem spots on those than on others.
No, you're exactly right. And when I was calling tension or compression, I was just explaining why you might see more cracking back in this region is that, the gravity is causing that. And it's not the gravity, fatigue is because stress cycles. So it's going to mainly come more because there's a little bit of a bouncing effect potentially out there that might increase the propensity to crack on the back side of the pole for a cause. And that's the only reason we're trying to note. There still are some cracks on we'll call it the compression side, because it can come from the torsion that's happening and the combined stress state. But all we're trying to do on this I'll call it the relatively small samples that we're having, but if we're trying to just make a note, is there anything on a traffic signal pole or something that might provide the inspector with, yeah, I'm going to sample all around the pole, but I really want to focus on the region because that's statistically where most of the cracks that might be there. So anyway, that's all we're trying to provide at that stage. And you know, I constantly, like on our weekly meetings, I always feel like I'm saying, hey, by the way, it's not our goal on this project to find the source of the cracking. Our goal is to say, is there cracking and how can you repair it? And that's, we need to, you know, make sure we stick with that. But still, as researchers, we want to say, yeah, what is it that's causing this? Okay. And anyway, that's the only reason why I'm kind of showing some of that statistically what's on there.
Makes sense. And then last thing is, have you talked with other states that are inspecting all their ancillary structures like routinely to get kind of feedback or
Yeah.
input from?
We haven't really reached out to any other states. We historically we've been looking at details. That's where you get like high mast poles. They're almost like 50 snowflakes. I mean, it seems like every state's got their own little thing. You know, we stand on this leg when we weld, and you know, anyway, everybody does things a little bit different. We use a socket connection. We use this, and so they're all a little bit different. But it's not like, gee, this state has the problem, that one doesn't. I mean, every state's got some different little effects, it seems like, on these structures. We do need to kind of look and see our other states have different repair techniques, and that's something we would do.
Yeah, I was thinking more like the inspection kind of program that they use.
Exactly. And, you know, on the inspection side, it's this, we think the phased array is opened up to where inspectors can get out there and do a lot better job, but you do need to be trained properly. And that's, I'll get to something, like on a bridge side, if I go out and we're doing bridges, we like to do experiments, get data and validate our FEA analysis so that we know what we're doing with our FEA and so on. It's kind of the same thing here, is that, you're sending somebody out there, they can't see the cracks, you've got to look at this. So it's important that your inspectors actually have the ability to find things. I remember, Rob Connor at Purdue does this thing where he looks at the ability of inspectors to find certain defects, and you'd find that, bad ones sometimes found things that the good ones had, but then some of them were just like, they couldn't find anything. And it's the probability of detection, right? You need to make sure that if these defects are there, that your inspectors can actually find them. Because it is one of the things where it doesn't jump out at you. You can't like say, oh, there's the crack right there, I can see it. So we're hoping that we can kind of provide something so that the inspectors have some confidence that, yeah, they can actually find these cracks. Anyway, thanks for the questions.
So I'm mainly interested in high mast poles, but maybe the other ones too. Like you're going, and I'm not sure how much you got into the field or how many structures you looked at, but kind of like, what's like how many poles have cracks, or what percentage, and then how bad are they?
Well, that's where we're at. We've got all the data, and we
Yeah.
did find, I can't say 31% or something,
Yeah.
We're not to that stage yet, but we'll be
Right.
able to say of the 120 poles, or if we want to say of the 40 high mast poles, here's
Yeah.
what we found. Of the 40 traffic signal structures, here's what we found.
Yeah.
And that's what our goal is, to be able to provide that and say, here's the percentage of cracks. And so, and by the way, it's not like, gee, let's just say 100% of the poles have cracks. Well, if they're
Right.
just tiny, whatever.
Right.
Okay. It's not bad, but it's more of, what's the percentage of the circumference that's cracked?
Yeah.
What's the length, the size? Because
Yeah.
when you get to all this stuff, it's like fatigue is not like, a crack in a structure is not like the sky's coming down. Is the crack growing? And at what rate is it growing? We have a 75-year design life for these. So do I have enough to meet that? And that's, we want to try to provide some indication of, here's what we found.
Yeah.
And here's the percent that might have this, and so on. Right now, there's not been anything where I like, oh, wow, we got to get out there and do something
Right.
on this pole yet. I mean, from the data that we looked at. Now, again, 40 high mast poles is a very small percentage, but we still want to say, here's what we've kind of found on this.
Yeah. Yeah. And then I'm sure it makes a difference if the pole has been out there for 5 years or if it's been out there for 40 years.
Yeah, but again, some of this stuff too is, and this is where and I'll focus on high mast poles. That's what I've done a lot of in the
Yeah.
past, right? You got there and say, yeah, well, this has been out there for 30 years and it's got cracks in it. Well, we found you know, that a lot of these things happened when they pulled it out of the galvanizing.
Right.
It's like, it's already cracked.
Yeah.
Well, okay, now I've got that out there. The worry is that crack growing? And that's where like some of this to be able to say, yeah, you got some small cracking, you need to come back in a year or 2 years and look at this again and recharacterize it, say, has the cracking changed? If it hasn't, then move on to the next pole. It's
Yeah.
not a big issue. But if you go out and you say, you know, this crack was 2.5 inches long, now it's 3 inches long, or here's the depth, then, and that's one of the things you may want to say that, okay, you may want to consider repairing this.
Yeah.
Like one of the things we had found, Mike Engelhart led the last project that we had done this on, and you know, they're finding that, you know, as far as repair, if you got through thickness, they need to be repaired. I mean, it's replaced. You really can't repair that.
Yeah.
You don't want to get to that cage. If it's through that stage, if it's through thickness, you usually can visually see it probably.
Yeah.
You know, but you do find that when you look at crack growth versus time that, you know, you want to get to the stages as that slope of that curve is increasing. You want to make sure you don't get to that stage where it's growing quickly.
Okay. And then just one other thought, you know, like with high mass poles, you say when they dip it in the galvanizing, that's what the cracks form. I mean, and I'm sure the fabricators know about that now. Are they checking that? Or
My understanding now is most of these fabricators are actually looking right away now and seeing
Yeah.
where they weren't doing that 15 years ago.
right?
These things were coming out and they were getting out there, and you know, we did a whole bunch of little, and that's where we found out, well, this is all happening most of this is happening at the galvanizing stage.
Yeah.
And again, it is one of these double-edged swords that where we galvanize them to increase their service life, and the service life's being reduced because they're cracked from the galvanize. You know,
Yeah.
it's one of these things. So, and again, I do think if you're going to look at your details, you know, you should start looking. It says, well, do you want to use that ground sleeve, or do you want to try to maybe just use you know, no ground sleeve, but maybe thicken that wall? I think the cost of the material, there is a limit obviously to the cold bending and so on. If you get too thick, you can't get the radius that you need, but I don't think we're talking about that. You know, you're talking about going up to a 7/16 or ½ inch wall thickness, and all of a sudden you can now just use the nice little single weld around it, and maybe that's a cleaner detail. It's easier to inspect. It's just something to think about. So, and take it with a grain of salt. I've kind of said, I've been back in it for a year. So, but it is something to think about, you know, what you're putting out there.
Yeah.
So I do think like the ground sleeves, I mean, our pastor said they do behave pretty well. I mean, you know, but it is a lot more, you know, complex to weld because you've got a lot more welds to actually look at and so on.
Yeah. Right.
Carl online had a comment on that. The ASHTO specification requires that the fabricator UT test after galvanizing to spot any toe cracks.
Yeah. So that's, now they are inspected and so on. So it is, but.
Another online question. On inspection and maintenance, have you ever encountered or seen any fatigue crack or hairline cracking on the hand hole on those high maintenance or high mass illumination poles, 55 or higher? If you have, how do we prevent that from happening?
I haven't seen it. I mean, I personally haven't done that much, but I've not seen that. And actually, I wouldn't be laying awake at night worried that much about that. You know, it's, you know, and part of the problem, like when we looked at a little bit of this, I think on TxDOT side that they were a little bit frustrated because we kept on saying, okay, we have this, we needed more research on this, we need more research on this. And it got to the point says, nah, we're just gonna use ground sleeves and everything, just stop doing the research or whatever. And part of it, you know, when you look at this, it's not a real surprise that this is a complicated problem. This is about as you know, lack of redundant of a structure as you can have. It's a flagpole. There's one connection, you know, so, you know, you can see it, but it is a critical connection. So, but the handhold cracking, I'm not that worried about. You know, David sent me some pictures of someone that had some vertical cracks. Look like they might, I actually asked them, it looks like more like a hydrogen embrittlement type problem that was probably there from the, but again, it's just growing. But I wouldn't be that worried about up at the handle unless it's some ridiculously large and it's growing or something like that. But if it's something where it happened, you know, you're talking a few feet up from it, and it's not something that's all around the base or something like that. It's a very localized region. So I personally would not be that worried about that, but someone else may come and say, no, you're wrong. And I'd say, okay, maybe you're right. But in my opinion, that's just not something I'd be that concerned with. Any other questions or comments?
Nothing else online.
Okay. Well, again, thanks for the opportunity to talk.
So that brings us to another kind of open discussion that would take us to lunch. I don't know. That was a great presentation. It was good to see kind of where you were. Again, anybody who might know of any cost structures or traffic signal poles or anything that are coming down, please reach out to David Fish. He is the point of contact for that research, and he can get that information to Dr. Holle. Yeah, we've been looking at kind of standardizing the base connection. That was a huge topic last year. We have some structures that have stiffeners, some structures that have the ground sleeve. All of them some of them look a little different. So we're trying to, for similar structures, kind of have this similar philosophy around it. So that was really kind of one of those things that we were definitely looking into. And it seemed like different fabricators had different opinions on whether or not the stiffeners were easier to fabricate or the ground sleeve. And, everybody has their own way of doing things too, right? So, but I guess, does anybody have any topics or anything that they want to bring up? Anything about materials? Teresa's here if you have materials and testing questions. I had to.
Check, yeah. You're going to a higher standard, LTS 13?
So we're going to be
For
going to the LTS 6, which is the current standard specification that has the fatigue
Yeah,
with it. But since we had done the research for the fatigue aspect, we added the ground sleeves, right?
so we're going to have the ground sleeve in the new, still in the new version?
I believe that we're keeping the ground sleeve.
Okay.
Yes.
Okay, that's what I was wondering.
So, I mean, for now, and
Yeah.
then if we want to discuss it after this research and stuff like that, then we can talk about that when we move it up to the LRFD. But
Okay.
we are so close. I'm not changing it this time. But again, we will be looking to move it to LRFD once we get all of those LTS 3s up.
Yeah.
Then we'll be looking at moving the rest of them to LRFD.
For HMIP cracks, is there guidance on whether the pole shall continue to be in service or shall be taken down?
So that is what this kind of research is for, is to kind of figure out what is the deciding factor? How much can we really get as far as, the design life? Can we repair it? Do we need to take it down? At what point do we need to do that? Currently, I don't think TxDOT has like a hard rule on that. But we are trying to work towards that, right? Because as we start, inspecting more of these, as in like Greg's contract does, it's kind of like, okay, when they see something, now what do they do, right? And so we're trying to get those answers so that people know what to do in the field when they do find them. So after lunch, Ryan's going to be presenting on geotechnical updates, and that's going to be kind of using the standards design, since we're moving to LRFD with the geotechnical design. And then we'll have a break, and then we'll be presenting kind of where we are on the resources that we're going to have out there for like the design consultants for using these standards, and the applicability of the standards. If they are slightly off standard, what can we do, or do we have to design them as a one-off, that kind of stuff. So that'll be this afternoon as well. Well, I guess I'll go ahead and let everybody go back to lunch. We'll be back at 1. It will be off site, so the little extra time is helpful with that as well. So, okay. Well, then with that, we will break for lunch, and I'll see everybody back at 1 o'clock. Thank you. Welcome back. It is 1 o'clock. So this afternoon for our TASIG agenda, it's going to be foundation design and then upcoming design resources for the structural design and use of standards. So with that, I will go ahead and pass it off to Ryan to talk about foundations.
Thanks, Courtney. I appreciate it. Good afternoon, everybody. If you don't know me, my name is Ryan Eves. I'm the geotechnical branch manager here in Bridge Division. This afternoon, I'm just going to kind of go over, well, first of all, I'm going to spend a little bit of time at the beginning to go over the existing standards and how to use them a little bit and some things to look out for when you're using those standards for design. Let's see here. Let me transition here, sorry. So I'll go through kind of the list of current standards and how they look now. We'll talk a little bit about the design approach, which kind of will go, will be relevant with regards to how to use those existing standards, just to kind of give you a better sense of what goes into the design of laterally loaded structures. I'll show a couple of examples of how those standards are used from start to finish. And then we'll talk a little bit about some things that we're working on and some updates that you can expect to see from us and the geotech side of things. So here is an exhaustive list of traffic structures that have deep foundations. So, you know, if you're using any of these systems that you see on the screen here, they require a foundation design. So they're sitting on a drilled shaft and require some sort of foundation design. I'll go through each of these very briefly. And actually, you know, there's quite a few different things to look for here. So the point is not necessarily to, you know, try to take in everything that I'm mentioning, but what I'm trying to do is just kind of give you a sense of how some of these standards are different, what particular things to look out for when you're using them. So first we'll start with large road signs. And so we've got this chart split out here with the relevant foundation standard. Now there's other standards that are tied along with it. Each of these standards references some sort of soil strength parameter. So most of them are based on the TCP foundation or TCP in situ test that TxDOT's used for a number of years. And we've also listed on here the design loading conditions and things like that. So one thing that I'll mention and I'll go into after we've gone through some of these standards here is that we've updated, and if you're plugged into what we're doing in the geotechnical branch at all, you've probably noticed that we're updating to LRFD-based design approach. And so that kind of changes how these standards will be used. And so we'll talk a little bit more about that as we move forward. You may recognize some of these and I apologize, some of these are pretty small, but for large roadside signs, it's based on pole size, which is determined from the other portions of the standard. This one here has, as I mentioned on the previous slide, has both NTCP, which is on the left side of the screen here, curves based on TCP values, but also on the other side of the screen, curves based on C and phi values. So if you've got laboratory test data, those can be used for this as well. So one thing to consider here is when you're looking at and trying to determine what the soil strength is, these standards typically assume that your soil is uniform, which may or may not be true. And so, you know, a lot of the standards will indicate, hey, here's the zone that we're looking at, here's the zone that we're concerned about. And we'll talk about it when we talk about laterally loaded structures as to why that's important from a design standpoint. But you have to kind of pay fairly close attention to the notes on this one and some others to determine exactly where, you know, what area that we're concerned about when it comes to soil. Overhead sign bridge also has the same soil strength parameter inputs. For this one, there's two types. There's the two shaft footing, which is primarily axially loaded. So once you kind of separate it into two shafts, we're looking at uplift. And then the chart that's all the way on the left, you have laterally loaded structure, so single shaft or single column elements. And on that side, so at that side, you're looking at the moment. So the moment's kind of the target on the curve. And on the other chart, you're looking at the uplift loading. One of the things that's kind of important here is if you look in the general notes, typically there's, if you look closely in the general notes, you'll see that it has you add an additional 3 foot of the 3 foot that's exposed above it. Some of the standards include that, some of the standards don't. So you need to read the notes or the fine print there to make sure that you're adding the additional exposure that you need to. Looking at monotubes, sign structures, the foundation elements are the same size on this one. So there's not a difference in size or reinforcing for the foundation. It's all 48-inch diameter shafts. But these are tabulated rather than a chart on these. And so you derive the loading from the chart here, and then you can go and look based on the TCP value and post height on the other side what the foundation links are. This one also has, this is a question I get a lot, is how do I handle when I run into rock? And for laterally loaded shafts, and I'll talk a little bit more about this too here in a little bit, in a little bit more detail, but for laterally loaded shafts, you know, it's not quite as straightforward it's not quite as straightforward as an axial design. You know, if I'm designing like a bridge foundation, for example, you know, once I hit that rock layer, I generally know like how far I need to go in order to mobilize the resistance. But for laterally loaded shafts, laterally loaded shafts, the relationship's not quite as linear. And so you have to be a little bit more careful about, you know, hey, you know, once I hit, you know, instead of saying once I hit rock, I'm done, you know, there's a little bit more to it for laterally loaded structures. So for the span structure, it's a little bit different here. We actually have it tabulated in a chart. A lot of the standards have things separated between clay and sand. Here we don't. Here we've kind of taken this and created an envelope. So it, you know, it's the actual blow count. The blow count applies to both. I'm going to go into more detail on this one because I have one example related to cantilever overhead sign structures. But again, this one's based on, we provide C and fee on this one as well, and this one's based on either the controlling of the moment and the torsion here. Roadway illumination poles here, that says the same 30-inch diameter foundation for all of them, just depending on the mounting height here. Then we go to high mast illumination pole. There's charts for each of the 4 types depending on height, and they have different drill shaft requirement or different drill shaft size requirements for each of those. But those charts work kind of the same with, you know, TCP blows per foot for each type of structure. And then these are also separated by wind loading. Getting towards the end here, a traffic signal pole is again just based on the span lengths. So you find the span lengths in the bottom table, then you take a look at the top table and you find the foundation. You find the foundation load and the foundation length in that table directly based on the foundation type. And then finally, the intelligent transportation systems pole, where each of them has their own separated, you know, foundation length in the table. So again, the big thing is, and all of that's just kind of, just to say that generally there's a lot of different notes. Some of the standards handle things slightly differently. So you can't just assume, hey, since I've done this other one, this one will look exactly the same. So it's important to take a look at the fine print, take a look at the notes and make sure that you understand, you know, the monotube structures have that 3 foot included in the design, but the overhead sign bridges do not. So you have to pay a little bit closer attention to what's going on there. So I'll pause here for a minute and talk a little bit about the design of laterally loaded structures. And I think I alluded to this a little bit earlier, but I'll go through it again real quick. Those of you that are familiar with designing bridges, the philosophy here is quite a bit different. These structures don't have a lot of axial load or axial dead load by themselves. Most of it is lateral wind load, which is quite a bit different than a bridge. So we're looking primarily at lateral controlling the design, which isn't all that common for bridges. You know, we still check it, but it doesn't necessarily control the design all that often. And so we have a couple of approaches approved by AASHTO to take a look at these laterally loaded structures for sign structures. There's Brahms method, there's you know, using L-pile and PY analyses. Often these are controlled by a transient loading as well. Most of the time when we're doing these analyses right now, we're using static loads for the most part. That's fairly conservative. We have this kind of general idea in the geotech world that whenever, something is loaded cyclically or loaded with transient load, that the soil may behave a little bit stiffer. But from a design standpoint, using these methods and using these approaches, we kind of treat it as a static analysis. So that's kind of on the conservative end of things. And then the other thing to think about when you're designing laterally loaded structures is how far away is my information, or how comprehensive is the information that I'm using, to design the structure. So, it's very different if I have a boring that's just sitting right on top of the foundation than if it's, 300 feet away. It just kind of depends on whether or not, kind of depends on, am I, relying on a rock layer? Do I believe, based on the information that I have that, that's where the site is uniform across the site, et cetera. So, so those are the kind of things that, when you're thinking about this from a geotechnical standpoint, trying to figure out exactly how variable the soil is and how much I can rely on it. Because, if that information is relatively far away, then I might make a more conservative assumption based on that. So I mentioned this before, as all standards currently use the NTCP value, a C or phi, as we kind of saw a little bit earlier for foundation lengths. Long term, these standards will be updated to the LRFD-based design approach, and the biggest change, at least for this, is the in situ testing will be switched from TCP to SPT. So we're not collecting that data anymore, and actually that manual is in place and active now. So projects moving forward from this point that have, from a design standpoint, won't be collecting that data anymore. And so long term, we're kind of looking at options in order to better implement the SPT values and the, the soil strength parameter determination into the future standards. But for now, if you look at Appendix 2 in the geotechnical manual, which I'll have an image of it here in a couple of slides, we have a general conversion factor that can be used here for clay and sand between the TCP and SPT value that can be used on these standards. Also, using SPT, you can actually directly derive what the angle of internal friction is based on the chart that we have here. This chart's in the manual, but it's also in AASHTO. And I'll kind of pick at that a little bit more as we move forward in this presentation as well. So when I'm determining what soil strength to use in these standards, and even this applies to, when the standards change a little bit moving forward. Again, as I mentioned before, we're concerned about proximity. I can, if I have an existing TCP boring, while the standards are still in TCP, I can look at that information and factor that in as well. How much data do I have? Again, how are things, do things look like they're changing quite a bit or are highly variable? Looking at soil type, this is a question that I get a lot. Some of the standards are split between clay and sand. So which one do I pick? Well, it's, as always, there aren't that many places in Texas that have, a pure sand or a pure clay. There's usually somewhere in the middle. Again, if there's any question about that, or if there's any issue or any kind of gray area there, it's often better just to kind of look at it and say, well, does it make sense for me to take the more conservative approach on that one? Can often be the answer. How uniform the soil is with depth, as I mentioned, from a laterally loading standpoint, it's not as linear. If the soil strength gets stronger, it might not necessarily affect the length as much, because I'm concerned about, maybe top deflections, what controls the design. So actually, having a fairly weak soil layer at the top with something a little bit harder at the bottom doesn't necessarily shorten the shaft, or it's not quite as linear when it comes to, the design as axial, as I mentioned before. I might also look at future improvements or change of conditions. So, if I'm in a drainage channel that might erode, or if, a future widening might change, the exposure height, that might be something to consider. Also looking at shrinking or swelling soils. So if there's issues like that, maybe the disregard depth needs to be a little bit deeper. So there's still some kind of, there's still some, analysis or some, discernment that needs to be had regarding how to approach these things. So I'm going to spend a few minutes here going through some examples. So I've got an overhead sign bridge from beginning to end and a cantilever overhead sign structure. We're looking at a 2-shaft footing for the overhead sign bridge. So the first one here, the foundation diameters vary between 24 and 54 inches, and the foundation embedment varies quite a bit. My given values here is I've got a 93-foot span length. I've got 2 different tower heights, 26 on one side, 22 on the other. The design height at the center is 27, and just for purposes of discussion, from the borings, it tells me that my average SPT penetrometer value is a uniform N equals 20 blows per foot. So I take a look at what county this is in, and I determine that this is in zone 2, 90 miles per hour above the ice line. And so that immediately directs me to the Z2I standard. When I take a look at this chart, I take a look at the span length, which is closest to 95. I go down to my column heights of 23 and 26, which kind of put my foundation loads at 70 and 80 kips, I believe. And it tells me there what my column size is also, which is the average of the 2. And so I go to the foundation data chart that tells me that there is a 36-inch drill shaft with 8 number 9s due to the correlation to the column size there. And then looking at, this is an excerpt from our current geotechnical manual, and looking at this, these translations between the SPT blow count and the TCP blow count. In clay, we would use 30 blows, in sand, 40. And so if I take a look at this chart here, which I don't have divided between clay and sand, I have a 36-inch diameter drill shaft. These charts allow me to extrapolate between the 2, but I'm taking a look at the uplift load, which is 70 and 80 respectively. And so if I look at these charts and just kind of extrapolate upwards, that puts you at a foundation length of 7 and 6, and then you add that 3 feet because the standard indicates that there's a 3 feet exposure at the top assumed. For sand at 40 blows, I do the exact same thing, which puts you essentially right on that datum line for a 80 kip loading. And so that puts you at right about 9 feet. So that's how that standard works, and that's kind of how you work your way through that one. For cantilever overhead sign structures, as I mentioned before, we're looking at lateral load, so a little bit different. So cantilever span, here's my givens here. So 33-foot span, 23.3 foot column height, design wind height, same height as before, 27 feet. An average SPT penetrometer value is at 15. That's from my boring in Hill County. So again, looking at Hill County, that puts us in zone 4. And so I'm looking at the COSS Z4 and Z4I standards, kind of doing very similar things here. Looking at the zone 4 70 mile per hour chart, the torsion's the same throughout the entire height because that's primarily dependent on the truss length. And then if I take a look here at my 23-foot height, that puts us at a moment of 243 kip feet. And so taking a look at the other chart, I've determined my anchor bolt size over there, and that tells me that there's a 48-inch diameter shaft due to the pipe outside diameter being 24 inches. And then that takes me over to very similar charts here. Now we have this one divided up between sand and clay. So taking a look at the sand first, if we use the NTCP values, we multiply the SPT by 2, that puts us at 30 blows. And so if I look at that top chart there, the torsion appears to control. So that puts us right at around a 16-foot length up to 19 feet. And so if I look at the second method, which would be to translate those SPT blow counts to the angle of internal friction based on the chart in the geotech manual, I get roughly the same answer. So that puts us, based on that chart in the bottom right corner here, that puts us at a 31-degree friction angle, or around 16 feet again, up to 19. And the same exact thing with clay, except it looks like the moment controls in the clay. Again, still adding that 3 feet because the standard indicates that it doesn't include it in those charts. So that should hopefully kind of give you a better idea of how those work. Now, just to kind of give you a better sense of what our future plans are, So we talked about kind of how to get us through and how to approach the standards with the new methodology. But in the future, our ideal scenario would be to kind of, update these and refine the design per current AASHTO requirements. Now, most of the current AASHTO requirements point you to the bridge design-based approach, which again, as I mentioned, will produce a very conservative static design. And so as part of the research, one of our goals is to take a closer look at that and see if there's anything we can squeeze out of that and kind of see if there's a way for us to approach it to kind of, refine and decrease the lengths of some of those shafts, because some of the recent designs are, based on extreme event loading, but also with some additional factors based on that for like a static loading, as I mentioned. So we're hoping to be able to take a little bit of a closer look at that in that research. And then also trying to figure out the best way to approach, the design approach is getting a little bit more complex. And so we like to try to keep these standards as user-friendly as possible. So we're trying to look at also different ways of making sure that, those standards are still approachable and easy to use, with those parameters, because I think there's some value in that as well. To summarize for standard updates, we're kind of looking at in the long term some design updates, and then also adding NSPT standards and adding C and FE into more other standards, just to give more options for how to approach it, especially as we're kind of waiting to get those new curves calibrated. So if you have laboratory test data, you can, it's encouraged to try to use those values and try to correlate, the C and FE value if possible. So again, every standard is different, so it's really, really important to kind of read the notes on usage and how to use them. There's little small things that you'll need to catch. Everything's pretty clear in the notes. It's relatively easy to follow, but you just have to make sure to go back and find them. The other thing I wanted to emphasize too was that, it's not necessarily just a plug and play thing. I can't just look at the boring and say, at my predicted depth, the TCP tells me this. It requires a little bit of discernment, based on how far the boring is away, as we mentioned, how uniform things are at the site. It's good to kind of do a little bit of an investigation on your own there and using all the information you have at your disposal to make the best decision, because we don't want issues with these sorts of things down the road. So keep an eye out from us from additional updates, and feel free to reach out to us if you have any questions. And that is all I have, I believe. Sure. Yeah, I mean, the main thing is I think there's some general idea that with the, being able to use, knowing that we're dealing with transient loading, or we're dealing with something a little bit different than with bridges, that I think, when you're looking at kind of a foundation design, typically we use kind of our depth to fixity, or depth to where, the top of the shaft stops moving, at least from our standpoint, as kind of the general benchmark. But there's some idea out there that, with these types of structures, that might be, kind of excessive or overkill. And so there's not much information, if you dig deep into AASHTO regarding that, what that, where, I guess, how much you can, kind of milk out of that, I suppose. And so I think that's the big thing that we're looking at least from the design standpoint, just trying to more standardize that procedure, and, to determine exactly where, these types of structures need to be. That's the main thing. Yeah, because like sometimes, like most, like, because there's different philosophies on how one might handle it. Like some folks just limit the top of shaft deflection, because, if you shorten it too much, you'll have kind of rigid body movement. Or at least an analysis would show that you have rigid body movement. If you use Brahms method, you'll see that that allows for some shorter shafts, and so there's a little bit of kind of a discrepancy depending on how you approach it. And so the big thing would be is just kind of to, at least for us, set a procedure that we can use uniformly, rather than have to have that conversation every time about what we're comfortable with. Yes.
Once in a while we have to design it. Have a full foundation. We do it like once every 2 or 3 years.
Mhm.
Is there, and is there a procedure laid out, like in a manual somewhere on the way to do it? I mean, it says like take the end value over the top third of the shaft. And of course, you don't know how long the shaft is, so you don't know where a third is. So yeah, I guess you have to assume that you have to assume a length, and then you keep messing with it till you get to the, till it quits changing. Is that written down anywhere, or?
I think it is in some of the standards. Like it's iterative. I think it's written down in the standards. I'm not aware of any other. I think there might be some example standards in there. I don't know if there is
in
for
the
elimination
geotechnical manual?
For laterally loaded structures, no, I don't believe so. I don't think
Okay.
we have extra information on that.
Okay.
But yeah, I mean, it's iterative, and
Okay.
again, it's not necessarily an exact science either. I mean, maybe even if you've got that situation, you may have to look at it closer and say, well, if the boring's particularly far away, or if there's, some other uncertainty there to kind of knock it down a little bit too. So like that's generally a good idea, because again, part of the design of the laterally loaded structure is that top deflection and limiting that top deflection. So a lot of these standards, especially with the illumination pole standards, where the foundation diameter changes a little bit.
Yeah.
I'd have to go back to the numbers, because it's been a few years since I've looked at that last, but that one may be governed by top deflection. And so that's especially important, and that's probably why that note is in there, so that you can, so that if, we exceed, like, even if you've got something fairly hard at the bottom, if you've got really weak clay or something like that at the top, then, maybe the deflection controls the design, and that's what's driving, both the size and the depth. And so the point of all of that was to say, essentially, is that it's a little bit like there's more to it than just like an axial design, like, hey, I hit rock, I'm done. And I get that question a lot. This is why I wanted to mention it too, is because I get that question. It's like, hey, we've hit rock. Do we really need to go, an additional 2 diameters?
Yeah.
And it's like, well, sometimes yes, sometimes no. It's the answer is not always as clear.
Yeah.
In this kind of load case.
Okay. And just one other question. So I'm used to the end value, the TCP, Texas Cone Penetrometer. What's the new one?
It's a standard penetration test. It's a split spoon, slightly different hammer weight, drop height, similar hammer energy. It's used nationwide for similar functions in sand.
Okay, so it's another.
It's another in situ test, just different drop height, weight, and different shape.
Okay.
Yeah, I mean, we anticipate potentially being able to use it in a similar way, moving forward, but we need to, that's part of the research too, is kind of setting, those correlations.
Okay. All right. Thanks.
Thanks. I'll be around for a while if anybody's got any more questions.
Guess I should go to the mic so people online can hear too. So I guess the next thing on the agenda was a break. I don't know if it's really time to do a break, or we just go into the next presentation. Next presentation. All right. We got this. Okay. So for those of you online, we've got some nice background noise of somebody blowing leaves. So there's this nice loud humming on the other side of the window. But anyways, it's to keep the landscape nice. So without any ado, Hunter will be presenting some of the design resources upcoming.
All right, so resources, the road ahead, what are we trying to do? How are we trying to change it, improve it? Just make it better, simplify the process and whatnot. So first up, working drawings. We're trying to build up what we've got, put it all together, simplify everything. So the ones we're working on right now, we're calling the elevation and design criteria working drawings. These are very much a work in progress. They're currently in a Bluebeam review right now. I call it a rough 30% review. And these are really going to become a guide for how we want to see sign sheets detailed. We want uniformity and consistency. I help do reviews, especially with alternate designs, and from every single consultant to district, the elevation views are different. And what we find is that it's done wrong, it's missing info, there's errors, and then we get the review. We've got to reject it because we find errors. And a year ago at a TASIG meeting, we kind of went to the contractors and fabricators and said, please help us find issues, find errors, put it in an RFI, because if we get an RFI, we can approve the review while we get a sheet revised. Well, contractors, fabricators aren't the designers. They don't, know it like we do. So we thought, how can we actually fix this process and improve it? So get into it. So we've got 8 currently developed, 4 for cantilever and 4 for OSBs. Trying to identify all the variants that we think we'll see. So first up, just a standard cantilever sign structure. So this is using your typical sign panels. And what we're doing is we're giving a guide for how the elevation should look, and then we're providing standardized tables that will be filled out, and we're actually developing a tool for that. But diving into the elevation view, this is calling out everything we need to see. So dimensioning of the sign panels, vertical dimensioning of the sign relative to the truss center line, locations horizontally along the truss, the length of the truss, tower height, etc., vertical clearance. Sometimes in these elevation views, they sketch in the truss. We don't really need that. It looks cool, but it also kind of complicates it. So what we're saying is just identify the center line, just so we have a reference point. Going into the table, so identifying structure type, roadway station, which standard it's going to be, which of the costs, Z1 through 4 or H cost Z1, span length, and then sign area. So that is the applied sign area to the structure. That just helps us because we can look at the standard design area. It's the length of the cost structure times 10 feet tall. Well, if you're exceeding that, then you're going to need to bump up a zone. So it helps us identify, like, okay, you're in zone 4. Why did you use zone 3? Well, this is why. And then tower heights, wall thickness, and your foundation design. So this, if you're using a standard, it's all pulled from the standard sheets. It helps us, quickly review because it's all in one sheet. We can take that and do our shop drawing review. Up next would be cantilevers, but with a DMS structure. So the existing standards and the future LRFD are only designed for traditional sign panels. They're not designed for DMS. And so with that, your elevation view, similar data, but you can see this table is much longer. So anytime it's a DMS, it's a special zone. You as the engineer of record have to complete this table, provide the entire design, sign and seal that you designed this structure. So diving into the table, so you can see a lot of the same stuff, but then we're breaking out the truss details. We need all that in there. For your cord and web members, not only just the member, but also the number of high strength bolts required. In the current standards, you have the member and then in brackets, the number. Well, we want to break it out a little clearer. And then your tower details, your base plate, your anchor bolts, all that relevant data. And there's a reason for it, and I'll get into that in a second. Now, say you have a double cost, 2 cantilevers. Again, using standard sign panels, you can use the existing standards. The table is pretty much the same as just a traditional cantilever, except we have a span A and span B length. If you have a double cost DMS, again, it is a special zone, so the table grows exponentially, but it's pretty similar to a cantilever DMS. For OSBs, again, following the same pattern. If it's just traditional panels, it's a standard, similar table. The only thing we break out is, the left tower, right tower, left foundation, right foundation. If it goes to a DMS, table blows up quite a bit. Again, left and right, but you're still filling out your cord, your web members, all of that info. And if it's an OSB with a cantilever, standard panels, slightly bigger table than just an OSB. Again, just a little bit of extra data to identify your span and your cantilever criteria. And lastly, if it's got a DMS, say you had traditional panels on the span, but a DMS on the cantilever, it is again a special zone, fill out the tables. And part of the reason we want to put the tables on the sheets is that the current process is you need to be filling out the cost and OSB special zone sheet. Problem is we don't get this filled out when we need it. So we have to go back and request it. This sheet should be provided when it's a special zone, tables completed, signed and sealed. Well, we don't get that. So we want this to move to the elevation drawings. So it's all signed and sealed in one location. So on the right, you can see the draft. We're getting rid of the tables. We're keeping the diagrams because those help you understand the data from the standardized tables. Up next, so this is our new design tool we're putting together. It is very, very preliminary. There's a lot of changes coming, but it's going to be awesome. It already is amazing. And so this is a design tool to help the engineer of record, follow the right process, provide the data, and reduce error. So first off, it's going to do some design checks to make sure that you've selected the right wind zone, the right structure, and all that. It's actually going to provide a list of standards to you for your use, and then it's also going to create those standardized tables. So here's a preview of a current version of the tool. We'll kind of go through all of it in little bits here, but starting in the upper left, you start filling out district, county, wind zone. You get to sign, and you either pick conventional sign or DMS. If you pick DMS, it's going to pop up a little window. It tells you, hey, when it's a DMS, you might be in zone 3, but you should at least bump up to zone 2, even though you're designing the structure. That's going to, verify that, for the change in drag coefficient, you're using, a good ratio for your estimated pressure area versus wind speed. Before moving on, if you look at the table on the right, you're going to see a lot of value and error issues. That just means you haven't completed the sheet. So if you see anything like that, you're not done and you got to go back and fix it. We go through all the inputs on the upper left. We get down, bottom right, everything says pass. It's great. The table looks like it's filled out, except you haven't defined the sign inputs. And so on the right, you'll see sign area, 0 feet squared. So 0 square feet. So you'll start filling in your inputs. In this case, a DMS 30 by 15. Everything's still passing. It now shows this sign area. You're ready to use that table. Below all that, there's a visualization. It's going to be a good way to see if you've defined the inputs right relative to your elevation view. And then below that, this is awesome. It's going to filter out your standards that apply. And then if you click that red DGN button, it downloads the DGN for you. Add it to your project directory, add it to your PSET renditions, whatever you do. Now going back, another feature we're building in the tool is, say you've got your inputs, you define it all, but you've exceeded and you're failing one of the checks in the bottom right. It not only tells you it's wrong, but it tells you why it's wrong. And that's really useful, so you can kind of figure out, okay, if I bump up a zone, is it going to pass? Or I need to reduce the sign area or something like that. So really helpful. And then this is an example of one of the standardized tables, formatting to be solved, but you can grab this, copy and paste it in Excel. If you've got Axiom, which most engineers do, import it in MicroStation, and you've got a huge part of your elevation view ready. Up next, and this is kind of a topic that we can go over at the end. We'd like to get some feedback and discussion. We're developing an ancillary structures guide, and we have 2 options currently proposed. The first would be similar to the current bridge standards guide, the guide to bridge standards. It's paraphrased, it's reduced down to just the core data, how to use the standard, what you need to know when you're using those standards, how they work together. Alternative is a more in-depth written design guide. And so we'd put a lot more data like what we've done, how it's performed, what we're doing, what's the state, where we're headed, what we're doing to advance those forward, as Courtney went over, the various specs for each item, and also just discussion of standards. So we'd like to get feedback on the 2 options, which the industry would find more useful when doing these structures. Can't be bridge division without talking about 3D modeling. So we're developing some structures with different 3D models that you can reference into your overall 3D plan set. If you're preparing public involvement drawings, just kind of shows it, gives a little more detail. We won't set a requirement for, as of June 2022, you must have these, but maybe someday. So lastly, in the streak, we always preach this at TxDOT. Since November 7th, 2000, there's been at least 1 fatality on Texas roads. That is 8,695 days ago. So that is at a minimum, 8,695 people that didn't make it home to their families and friends. You know, the Wi-Fi password, can't see it now, or it was on the screen earlier, heads up, phones down. Very important. You know, my wife, she's fine. She got rear-ended a couple weeks ago. Person behind her was on their phone. So car's totaled, but thankfully she's fine. So again, you know, your lives are more important than that text message or email. So that, again, we'd like to go back. First, any questions, comments, anything? So if, number one, if it exceeds the specifications of the standard drawing, there's a list of basic requirements. Two, if it's a DMS. If you have a dynamic message sign, it's automatically a special zone. But if you're within the limits of the standard, it's not necessarily a special zone unless you're changing it. If you want to design it, you know, an odd situation might be, okay, you're doing a toll structure, it's got equipment. Well, you've deviated from what you've got, and in tolling, there's deflection, displacement, rotation criteria, so maybe you need to beef up the web members. Anything that's outside the limits of the standard. Oh, the question was, what makes it a special zone?
Waiting for it to come on. So I do kind of want to add on to that. So there's the special zone where you're still using the concepts from the standards. You're still using the truss, the panels, everything like that. So it's conceptually the standards, but it's outside of the standards applicability. If you go beyond that, you stretch your span extra long or something like that, then that becomes a one-off design. And so so the SD sheet that we had that had the table, and then it had like the panel sizes and some of those details on it. So the current SD sheet, right? So those details are similar to what you'd find on the cost standard tables. When you do a special zone, those standards don't apply anymore, so don't include them in the plan sheet. So to try to keep from doing that, you know, we're putting on the information on the elevation sheet, you know where it is. We do have to include the details for that because the standards don't apply anymore, but you still need this information. But again, the concept of what you're doing, the member sizes and everything like that are within the standards. So like if you have a DMS, it's technically not applicable to the standards, but you can still use the standard tables using engineering judgment and stuff like that. That's what the Excel table is trying to help you with, right? Let's select a standard truss sizes and every configuration that we have, even though you're kind of outside of the range of applicability. Now, if you start going extra long, so your cantilever is over 40 feet cantilever, you're going to 50 or something like that, you're going to have deeper panels. You're going to have to majorly increase the sizes. You are now on a one-off design. So none of our standards are applicable unless you want to take them, check them yourself, but you're going to have to sign them as one-off details. The idea with the elevation working drawings that we're doing is you can still use that. That tells you what information we need, even on a one-off detail, but you are going to have to use your own connection details and things like that. So there's the standards, there's the special zone, and then there's just you're on your own, detail it yourself. So I just wanted to clarify that because it's not just standards or special zone. There's one that's off of that.
Online question here. Is there a link for downloading the sign structure tool, and does it help in actually designing for those special zones?
So it is very, 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 very preliminary. It will not be posted until it's ready, but I'm thinking it will be on the traffic standards webpage with the cost and OSB, and we'll have these working drawings, the Excel. But until it's ready, it won't be available. And no ETA on when it's available. Not going to commit to a date. Oh, it's amazing. I mean,
We would like feedback. So one of the reasons why we're showing you these things before we post them is to get your feedback. Is this stuff that you'd find useful? Is this information, like, are there pieces of information maybe we left out or we didn't even mention when we were going through it? That would be more helpful, right? Like if there's a little functionality here or there that we could add, that would be beneficial. We've been getting a lot of requests recently about they're changing out their signs, right? And so what they can do is they can use the spreadsheet and they can put in the new sign areas and see if their current design works or not. So we're seeing this tool as kind of helping people that maybe aren't the structural engineers or something. Maybe they're out there maintenance, they're in offices saying, hey, we need to change these out. Will it still work? And they don't have to come through us to do the calculation. Same with the ancillary structure guide. Please give us feedback. I personally like the one that's more like the guide to bridge standards. It's more concise. But if you guys want the narrative, we kind of have that spelled out too. It's just kind of how much information do you guys want? What would be useful? What format would be useful?
Just a penetrometer value, because if it is written as soil penetrometer value, I think it gives room for ambiguity. Yeah, that is on the, if you look at, I think slide number 19, slide number 9, where you present the design information. Yeah, the penetrometer value. Is it-
so, yeah, that might need to be updated. I will defer to Ryan on what we need to do there. You know, this is just based off the current, what we have out there. Now with the new LRFD requirement, we'll have to evolve that. So, but I'll let him decide all that and then I'll just do the work. Soil is voodoo to me.
Yeah, just one add up on the why DMS is separate, is special, is because the dimension weight make it hard, not the, especially the wind drag parameter. So basically, you cannot apply a thin plate drag parameter, wind drag parameter on the DMS. That's why, because the dimension weight, the wind load on it is different. So that's why we make it so special.
It's the drag coefficient, you know, sign panel is 1.2, DMS is 1.7. So it's a big increase. Anything else? Any feedback on the guide? Any thoughts? So it's either going to be something in this format, very brief. It's very much like the bridge standard one. It's just going to give you controlling criteria, you know, what spec, design speeds, just some background notes, different things. If there's been research, the alternative is like a fully written design guide, something written to put you to sleep at night, you know, if you're bored. We have both. We're working on both. We could go one way or the other.
Yeah.
We just want to know.
Okay, as someone who's not a structural person, I like the more detail.
One vote.
Yeah.
Anybody else?
And just to let you know, so internally within TxDOT, we've created the narrative one, and a lot of that is for us to document things. We did lose a lot of knowledge when Tim Bradbury left. And before he left, he was kind enough to let us pick his brain and get as much information as we can. And so we documented that. So we have all that written down. We're still going through and like editing and stuff, but it's one of those things as to what do the consultants need? We needed to document it so that we know kind of the logic behind of what we did, where we are and where we're going. In Bridge, we have a lot of different things, right? We've got the guide to the standard drawings. And so there could be a document where that's just the guide to the, you know, the traffic structures. Not all of his standards, just the ones that, the structural ones where you have to know how to pick out tables and stuff, right? And then we could have another one that's more like policy where it says, hey, use the standards. If that's not applicable and you're doing a one-off design, use the LRFD. Because I get a lot of those questions, right? Well, this is to the LTS3. Does that mean I can design my one-off to that? No, it doesn't. It means we're in the process and we're getting there, right? So there is some need for policy, or I know in our high mass illumination poles, our handholds are slightly smaller or slightly bigger than what the spec allows. Well, based off of past practice and stuff, we're moving forward with that. So we need to document when we're deviating from ASHTO, kind of like what we do with bridge. I know in bridge, we also then have a bridge design guide that would have like these commentary, right? I would prefer not maintaining 3 ancillary structure documents. But part of it is what information do you want and in what format and what location, right? Depending on who's using it. If somebody needs to know how to use the standards, that might not be a structural focused person who does calculations all day, right? But if somebody's doing a one-off, then they need more of the structural detail policy stuff, right? So I guess that's kind of what we're looking for feedback on. What do you guys want? Wait, that is definitely going away. So we get a lot of people actually putting that example in PS&E sets, even though on it says do not include on a PS&E set. So instead we're looking at actually like having more of a design example format that would be like an appendix to the guide or something like that. So that information would be there, but it'd be in a different format so it doesn't get stuck in the PS&E package. And more narrative and more explanation, so it's more followable.
Okay, we mentioned DMS drag coefficient. If that gets reduced in the committee, is there any discussion on updating it to the new drag coefficient?
So the standards will not be designed for DMS. If it were to be reduced and we decide to adopt that, follow that, and not deviate, then we would relook at the process for DMS. Would, maybe, possibly. Really, we have to see what other states do. What if the committee makes the decision? It's just more work for us, so we hope not. But we would make that decision later. That's what I'll abbreviate it to. Yeah, in that tool, we're going to provide instructions. It'll kind of be like moving the design example into the tool. Like, here's what you're doing. Here's some background. And that'll be in the guide and the tool, I think.
So on the drag coefficient, I think if it gets reduced, it may require doing some wind tunnel testing to be able to come up with, do we want to adjust or how that is going to design, which I would think we don't really want to do wind tunnel testing.
Oh, come on, that's fun. I've been involved on 2 bridges with wind tunnel testing. It's really cool.
Okay.
No comment on whether to make the change or not. I'm not on the committee. Don't want to be on the committee.
I'll just answer this one for you, Hunter. Any expected date on when the sign structure tool will be available to download? We don't have a timeline on that. It's under construction, but we will certainly let everyone in this group know as soon as that's published.
That was great. He got the clapping when he came up and when he went. You know who's actually doing the work. I'm glad. Okay. So this is the open discussion for more questions. Any other discussion topics you guys want? You guys have been very quiet today. I hope you're finding this useful. If there's any other topics you want to meet and discuss about, other things that you're interested in, I mean, I will set this up annually, hybrid at the moment. We'll see where we go with that. There will always be an in-person aspect to it because I think that's the best way to do the collaboration and kind of meet and talk to people. And I know the intent was to have virtual meetings as needed this past year. As you can see, we've been working on a whole lot of things, but there wasn't necessarily any topics for us to reach out specifically about. So we'll judge that kind of as the year progresses. If there is a specific topic that we want to reach out and get some input on, then we will have the virtual. Otherwise, we'll have the annual one. One question I do have is, especially since you guys were awfully quiet this year, whether or not you guys are wanting to do maybe like a half day as opposed to taking it over lunch. I want to be respectful of your time and to come back for, an hour discussion after lunch. It may or may not be beneficial to you guys. So, what are your guys' thoughts? Shortening it a little bit or keeping it the same length and we get out an hour early and you get an hour of your day back and people think you're busy? I don't know.
Hold the crowd well. I think it's hard to judge how long the discussion will go. So I don't know if you get an RSVP from people and if more planning to come in. We could condense it maybe, but if I remember the first time there was a big crowd and the discussion went on and on. So, which is good. You don't want to not have enough time for that. So depends.
Yeah, and so as the registration was, we had 52 people that said they would be in person. We have about half of that actually came in person. And we did get up to, I think, like 74 people virtually. So we do have a large attendance. We did block the chat and just do Q&A because sometimes it's a little bit more difficult to have the collaboration through the chat. And so, I mean, we can kind of play that by ear next year if people send feedback. And there'll be a survey as well for you guys to have more feedback. So Igor's going to go around and poll everybody and see what you want.
This format was fine.
You have a format is okay online, and then it's someone saying if you go to a half day, probably start at 8:30 if we push it to that.
That's really early. No,
Yes.
I was thinking about, starting earlier if we did that.
I think this format is fine.
Agree with this format.
So I'm good with this format as well, but I do have a suggestion. If there are items like that you're looking for feedback, kind of like the design guide, it might be helpful if we had that in advance a little bit to look at it, to be able to bring opinions to the meeting instead of trying to figure it out as we're here.
Noted.
We still have an hour. We can pull it out, start looking at it.
Hey.
I'm going to stand down, everybody else.
No, I'm no objections, current one.
I'm fine.
I guess we're passing it to everyone, right?
Yes.
I'm good.
Good here. I'm okay either way.
I knew there'd be at least one different answer there for you.
I agree, having the sheets in advance to take a
Right.
look at would have been best, and I'm fine with the current format.
I'm also okay with the current format.
Igor, your thoughts?
Oh, yes, I'm okay with either way.
And we got to come up forward and we got to do this front row too.
No committee. Well, at least not this one. I'm okay with the format and we should do the guide. Go around, guide, which version?
Nice.
I don't have any issues with the current format either.
Half day.
From the person who gets to work at like 7 o'clock in the morning. All right, guys. Any other input from online? It sounds like current format, and if we get out early, we get out early, but
Ryan, we do have a request to continue with LRFD geotech presentations, so it looks like we'll pencil you in on all future agendas. Thank you.
We can put them in on the updates at the very beginning when we do the updates on the standards and stuff like that. To kind of show where that progress is. Are there any topics or subjects that we haven't been covering in these that you guys are interested in? I would love topics. If somebody wants to draft up an agenda for next year, we can. I try to get a little bit of things that the fabricators would want to know, contractors, design. I don't know, thoughts? Get a little research in there too, right? Wow, okay, so next year I'm bringing coffee and it's gonna be over there. Hey, we got some support for that one.
I'd like to see another research update next year, see where they are.
Sounds good. On both of them, the geotech and the crack and the. All right, Greg, you hear that? You can't retire. You got to be here next year. Yes, we got a reason now. Okay. I don't know. Would it be helpful to get somebody from like the design consultant up here presenting as well? It doesn't have to always just be TxDOT up here. I mean, if any fabricators or design consultants or anything want to come up here and present on what they're doing or what they're seeing on their side too. But I also don't want to add to your work, so let me know if you want to do it and I'll reach out.
We have an online user that would like to see if any in the room has any more thoughts or discussion points about what Dr. Hellwig was mentioning earlier about galvanization. Does anyone have any thoughts on tweaking our detailing or fabrication? We'll open up the floor.
And anyone online who has thoughts, please put them in the QA and Sarah will be your voice. We're a little light on fabricators in person, and so please enter into the QA so that Sarah can be your voice. Typing takes a little bit longer, so. So while we're waiting on that, I did want to thank everybody. There's a huge team working on this stuff. It's not the only thing that they're doing. They're definitely helping out. All the work that you've seen done, I didn't do it. But we've come a long way on a lot of different things, and I know I'm anxious to get some of these things posted and out there. And there is a process with the standards and reviews and things like that. So I don't want to post something out there that I'm not 100% confident about and hasn't gone through the proper review and stuff like that. I want the stuff that we have out there to be good tools and something that everybody can get behind and make it helpful. So, but yeah, I have a great team helping me with all of this stuff and setting this up too. Yeah. So, come on. Applause for everyone. Come on. Anything, Sarah? All right. Anything else in here? Do we have to go around with the mic again and go, is there one last statement you need? No? All right. Well, I will wrap it up and thank you so much for attending. And we're always looking for feedback. So if you think of anything, let me know. I will send out some of the information as far as the guide and the tool and stuff for feedback. So, all right. Thank you. Thank you, everyone online.